So I just want to start talking about why I'm here. This is my son Aiden and my daughter Sienna. Um, Aiden was born in 2004 and he was perfect. We had no reason to believe anything was wrong with him. He was walking at 10 months. He did well in school. He played soccer. He played chess. And then in the latter part of first grade, he started having some vision problems, which led us to a diagnostic odyssey and finally a diagnosis on June 2nd of 2011 of ALD, a condition that we had never heard of before. Aiden was a late diagnosis, but he was eligible for transplant. So we moved our family to Duke, where he did receive a bone marrow transplant. But again, because he was late, he lost all of his abilities, and we spent 7 months inpatient at Duke and then 3 months at NYU in New York, and he passed away in April of 2012. And during that time, laying in bed with him every day, trying to research anything that could possibly save his life, I came across the fact that there was a newborn screening test for ALD, but not one state was putting it to use. And I knew at that moment that this is what I wanted to do, because not only would it have meant the difference of life and death for him, but for thousands of boys in our country. So after his passing, I started the foundation in September of 2012, and our main goal was newborn screening. Exactly 7 months to the day that he passed, exactly 11 months to the day that he passed, Aiden's Law was signed in New York, and we became the first state to start screening for ALD. And that's when I realized, what a broken system it is. Knowing that not every baby in this country is diagnosed for ALD, and that's when I began speaking in other states. Next slide. So this is a current ALD newborn screening map. We're currently in 36 states plus DC. The way we started with this is basically focusing on the larger states, California, Texas, Florida, Tennessee, just so we could ensure that the most babies were being picked up. So we've come a really long way, but we obviously have more to do, and we're hoping a few more states will come on board this year. Next slide. So as I mentioned, 36 states are now screening. Over 85% of the babies born in the USA are being screened for ALD, so we currently have about 3.6 million babies that are being screened. 6 states implemented ALD in 2022, and Alabama was the first state in 2023, we're hoping the other couple of states listed here will begin before the end of the year. Next slide. So not only are we working on ALD, but we're working on all conditions that are federally recommended. So there's a panel run by the federal government. It's called the Secretary's Advisory Committee on Heritable Disorders in Newborns and Children. And what we've been trying to do is have money go directly to the states so they can start testing sooner rather than later. So ALD was added in 2016, and it is one of 37 conditions that are now on the RUSP. Next slide. So we did some work last year with the CDC. Again, our work on the federal level is to get funding to go directly to the states, because what we've realized is it can take 10 years or more before any condition added to the RUSP is nationwide. So that's leaving so many children not having this important information at birth. So we worked with the CDC. They did have a grant program, and we reached out to the states that were screening for 31 or 32 conditions to let them know about this grant process. And they were very excited because it was the most grants that they've ever had. So we had 10 states that actually applied for the grant. 5 were funded, but it just goes to show what a lack of money there is, because 10 states were approved, only 5 were funded, which was about $2 million, and another 5 states were approved but unfunded. So the work we're doing this year is to try to get the federal government to give the $2.5 million so the other 5 states can be screened as well. Next slide. So as I mentioned earlier, it can take 10 plus years before any condition added to the RUSP is screened for nationwide. What I've realized, speaking in so many states, is that funding is the #1 reason. So if we had this funding federally, it would cut down that time, hopefully to 5 years or less, saving thousands of babies. So we're hoping that eventually that will be the case. The Newborn Screening Saves Lives reauthorization, which has still been stalled in Congress, that is an amazing bill, but unfortunately that bill does not have funding that goes directly to the states. The funding that is attached to that is for pilot programs and research, but they haven't thought about ensuring that the 50 states are screening for these conditions already recommended. And then RUSP alignment legislation that is spearheaded by Every Life Foundation. We're at 11 states right now that has RUSP alignment legislation, but the problem with that is that legislation does not always include funding. So it's kind of, you have this legislation, but it doesn't really mean anything. Next slide. So last year we asked for some appropriations language. We asked for $15 million a year with the goal of complete RUSP implementation in all 50 states by 2025. Unfortunately, we did not get it. As I mentioned, the CDC just had $2 million, which is a start, but we're still working towards trying to get them to understand we really need to give the states more money. Next slide. Yes, so this was what I was talking about earlier, the 10 states that applied, but only 5 were funded, and then the other 5 that were not funded here. Next slide. And then this is some of our resources that we have for ALD. So our 7th annual ALD meeting that was in March, we have all the videos up online. We have a quarterly consortium meeting, which has the newborn screening labs from across the country. So we get together on a quarterly basis and talk about cutoffs and any other issues that the states are having. The dates for our next meeting is going to be March 20 to the 22nd, 2024 in Brooklyn. Next slide. And then these are some other resources that we have as well. A few years ago, we created a parent's guide to ALD, understanding how overwhelming it is to get a newborn screening diagnosis, and how all of our families are living every 6 months and having to go through testing with their boys. So that's been a real help. At least, the families have said it's been very helpful for them. Last year as well, we created some psychological resources. So we have coping with an ALD newborn screening diagnosis and, how the families are dealing with that, as well as, how they're handling siblings that are unaffected and, just trying to talk about all of those things that that really affect our families. So that's also available on our website. And a lot of our educational resources are available in Spanish. We had them translated. So we also have a care package for ALD newborn screening babies. So if a family is diagnosed, we have some things that we send them. An MRI there, a book, it's called The Donut That Roared, just explaining to the families and the kids something to make it easier for the boys every time they have to get an MRI. Next slide. And then on July 12th, next month, we are hosting a virtual town hall for cerebral ALD gene therapy for cerebral ALD. We're so grateful that the gene therapy was FDA approved in September, but there have been, as many of you know, a few cases of MGS that have come up. So we're hosting this virtual town hall to have a discussion. Bluebird will be a part of it, and a lot of the families and doctors that deal with the gene therapy, just to give their perspective on how it's going. Next slide. And yeah, that's it. So that's a picture from our last meeting in March, and then from one of our Aiden's rides that we have in Brooklyn every year. Thank you.
And we have time for questions. Yep. Mm-hmm.
Elisa, I have a question about the funding that you were talking about, the $44 million, and then you guys requesting $15 million, getting $2 from the CDC. Is that for implementation? What it will cost to maintain the newborn screening in the states? How do they get that budget? Is dependent on each state legislation, cycle, budget? Like, what is the real number to keep it going?
Yeah, that's a very tricky question, and I wish I had an answer, but every state is very different. So in 50 states, they all do it differently. New York, for example, we do it in-house, which is less expensive than outsourcing to a company like Perkin-Elmer. So the $15 million was not for all the conditions for all years. So what we realized is not every state can move forward. Like, even if we said, Texas, I'm giving you $10 million today, they would have to look to see how they can add these extra conditions. Do they have the space? Do they have the equipment? Do they have the personnel to do it? So that's why we came up with $15 million a year for an ongoing amount of money, an ongoing amount of appropriations, to also understand that we now have 37 conditions, and with Screen Plus in New York, and hopefully Krabbe and Duchenne coming on to the RUSP, this should be an ongoing revenue stream for the state, so that when they are ready to go, they can ask for the funding and implement those conditions.
Thank you.
I gathered that, is it correct that they are only checking the male children, or are all children?
All children,
Okay,
yes.
good.
Yeah, there were some states that had issues with that. Michigan had issues, Georgia had issues, but we kind of walked through it, and, you know, to me, it makes sense to test both,
Yeah,
of course.
I mean, if
No, I
I'm
do
sorry.
biochemistry and genetics. I'm not allowed to touch patients, so I don't want to. So I'm going to tell you about a project that was it's called the Gray Zone, and no, this. So shall I do this myself? This is probably easier. Yeah, no, because there's some slides here that. So, I'd like to start with some basic genetics and some mind-blowing facts about our human genome. So our human genome consists of 3 billion base pairs, so those are building blocks. And each cell contains about 2 meters of DNA, if you would unwind it. And a human body has 37 trillion cells. So if you align all your DNA, it adds up to 74 trillion kilometers. And to give you some perspective how much that is, the distance from Earth to the Sun is 150 million kilometers. So if you take all your DNA, you can go from the Earth to the Sun 500,000 times. That's a lot. And so, there's another one. Oh yeah. Okay. So that's a lot of DNA. But only like 1 to 2% of this DNA makes up the genes. All the other stuff, which when I went to university was garbage DNA, well, now we know it's not garbage DNA. This is all very important DNA that consists of regulatory elements, getting the chromosomes together, structural repeats, and all other stuff, but we will not go into that. So, and you may think that the more the DNA you have, the smarter you become, but that's also not true, because we have 3 billion base pairs. We are over here, but you see, some of the plants have like 100-fold more DNA. Also something that I didn't know before. So now, if we look at our genome, we together, if we compare our DNA, we are 99.9% similar. But if we compare ourselves to the chimpanzee, we're 96% similar. If we compare ourselves to a mouse, it's 85%. With a fruit fly, we're still 60% identical. And with yeast, we still have 32% identity. But all this DNA, if a cell divides, every day our body produces 300 billion cells. And that means that every day, this DNA, all this DNA has to be copied, because if one cell divides, you get a daughter cell, and it gets identical DNA. And this is an incredible process. And you can imagine that if you copy something, that errors will be made. And there's a whole system in our cell that corrects all these mutations. But sometimes there's one that's missed. And we call that a de novo variant. And that's by itself not that so problematic, but if this occurs in the germline, so in an egg or in a sperm cell, then this information is transmitted to the next generation. And it's calculated that by every new generation, our genome acquires about 50 new variants. And most of these variants are benign or neutral, so you won't notice anything about it. But in case this variant, and these variants may even increase over time, and this is called evolution. And sometimes, if they are in a protein, it may lead to a new trait, and also genetic diversity. And to give you an example, if we talk about blue eyes, that's an interesting one, and it's still a little bit under discussion, but it's linked to a mutation that initiated in this gene, HERC2, and that is involved in myelin. No, not myelin, melanin. And that makes your eyes turn dark. And this mutation causes less melanin in the cells, and the result is that you get blue eyes. And this variant was first occurred in Northern Europe about 6,000 to 10,000 years ago. And by now, over the world, 8% of people have blue eyes. So this mutation doesn't make you sick, but this increased over time. So if we talk about variants and mutations, there are different mutations, and we're going to keep it simple. So we have their DNA, and the gene encodes a protein, and this is a normal gene. But if there's one of these nucleotides is missing, then the protein that's after this mutation is different. So we call this a frame shift. So the protein is different, and we know this is disease causing. You can also have a variant in which then suddenly there is a stop. So part of the protein is missing. And it is also disease causing. I'm getting very active here. But this one is called a missense mutation. That means that one building block in a protein is different. And in that case, it's uncertain. We do not know what the outcome is. And that's what we are going to talk about. In genetics, there are different ways to assess pathogenicity of a variant. And like I showed you, the frame shift and the nonsense, well, almost always these are pathogenic. If there's a deletion, part of the protein missing, it's almost always pathogenic. But if there's one building block changed, the outcome is unclear. And you can see that, thank you. with a missense mutation or missense variant, the outcome is uncertain. And next, please. And then we move to newborn screening. Next, please. So, well, Lisa told everything about newborn screening. In the United States are 36 states. Outside the US, Taiwan is screening. There are pilots ongoing in Japan, Italy, and Israel. And there was a pilot in the Netherlands, but in the Netherlands we will start nationwide screening in October. Next, please. But it's really important to realize that screening, population screening, newborn screening, is not the same as diagnostic screening. And I would like to explain that, because in diagnostic screening, a patient visits the doctor or the neurologist. There's a clinical assessment. Yep. And then the doctor thinks, well, this may be, click, ALD. And then you can do a request, you can do a lab request. So you take a blood tube, you send it to the lab, and in case the fatty acids are elevated, and there's a mutation in the ABCD1 gene, it's ALD. It's because you have clinical part, you have the biochemistry, and you have the DNA. So you have three things, and together they set a diagnosis. But in screening, the purpose of screening is to detect in healthy individuals a disease, but it's in the preclinical stage. So you're missing the clinical part. So in case you, yeah, please. So what we often see, and I received these reports because I have the mutation database, and I will tell you about that later. This is often what people receive following newborn screening. They get it from companies. They get it, so it's all anonymized. And then at the bottom of it says, click once, please. It says a variant of uncertain significance. So the commercial company found this variant. There's one building block that's changed, but they have no idea what it means. And that's causing, we call it a VUS, a variant of uncertain significance, but in practical life it's a very unclear situation. Family has no idea what to do with it. Physician who probably never heard of ALD has no idea what to do with it, and this is a growing problem. As it is often, these are missense variants, so one building block is changed. Well, they're not previously reported because we have no information on them. There are no clinical clues, so we just have the DNA and the effect on the protein. And sometimes we have biochemistry, but that's also not always not that clear. And these families have no history of disease. So what to do with it? Is this variant, is this mutation, or is that a disease-causing variant? But the consequence is that these families and these newborns, they go to see the doctor and they go into the follow-up protocol. And that's really burdensome on families. So the big question is, if it's a variant of uncertain significance or a VUS, the first question, is this ALD causing or is it benign? And we don't know that. But the outcome for these families is the same. They're all treated as a pathogenic mutation. Next, please. I came to realize at one of the ALD Alliance meetings that when we talk about variants of uncertain significance, we're talking about this. Sometimes families interpret variant of uncertain significance as this. We have a variant, and we cannot predict if it's adrenal insufficiency, if it's RUALD, or if it's myelopathy. That's also uncertainty, but that's a different uncertainty. Now, in case of a VUS, we are on this part of the scheme. So we first need to establish, if this causing ALD, with all the consequences of follow-up and monitoring, and or is this not ALD? And we should tell the family, you don't have ALD. Next, please. So, well, I mentioned the ABCD1 variant database, which started in 1999, and by now there are over 1,000 different variants in the database. Next, please. And here again, we have these pathogenic, likely pathogenic, uncertain significance, likely benign and benign. And as I said, for these deleterious variants, they're almost always pathogenic. However, for the missense variants, we see pathogenic variants, likely pathogenic, but also 114 VUSs. These are different VUSs. And interestingly, 113 out of these 114 VUSs came from either diagnostic testing, like newborn screening, or an exome sequencing. When there's a patient with an unclear diagnosis, you can screen the whole DNA and see if there's a clue or what it may be. But 113 out of 114 come from newborn screening. Yeah. And this is not unique for ALD. So this is also what you see in other newborn screening programs for metabolic diseases like Pompe, Fabry, oh that's too quick, and others, but also outside the newborn screening world, in testing for breast cancer or for hypercholesterolemia, about 20% of the results are VASs. So an unclear outcome. But this is this of course has a very big consequence for families. Yes, please. So in the last few years, there are a lot of publications about what to do with these VASs and what is the emotional burden on families of these VASs, but also for the clinicians. What should I do here? And so this has to be solved. Because the consequences, I mentioned it, there's a parental stress, there's anxiety, it also leads to increased healthcare cost, because you put these children into the follow-up procedure, but also for families. There's medical harm, because it may lead to unnecessary medical procedures, and eventually, if this keeps going on, there's a reduced trust in screening programs. And there's also reduced in decreased participation rate and reduced effectiveness. So we have to solve this problem. And I think for that, we have a way to do that, because we need to share information. In ALD, we have this unique situation that we have this database, which collects all the genetic, well, not all the, if it becomes available, genetic information. So I think what we can do is that in case of a newborn screening, if that information is shared with the database, and also the clinical information from the ALD expert is shared, we can link that together. So let's go to it. So newborn screening, this variant has been identified, and this is a true case. The outcome was, no, please back, one back. It was new in the database. So by definition, there was no clinical clue. So it was called a variant of uncertain significance. And then I moderate this, so I said, okay, it has been identified in newborn screening, and there's a reference, and now I know that it's the interpretation of uncertain is different, so we added this sentence, but it's never been associated with disease. So it is in the ABCD1 protein, but we don't know what it is. And now a patient visits the doctor, click please. There's a clinical assessment, genetic testing is done, and the same variant is found. So now we have the missing piece. Now we know that this variant is causing disease. So I can moderate the database. Click. Yep, thank you. And because it's only one patient, we always have to be a little cautious. So it moves now from a class 3 or a VAS, it moves to a likely pathogenic, because it's identified in one ALD case, over there, and in newborn screening. And so then we move on with the whole system. And then there's another patient assessed by another clinician, same variant, and now we have pathogenic. Because now we have 2 times the same mutation in a clinically affected patient, so the level of certainty increases, and then we move from likely to pathogenic. So in case there is a new newborn screening kit is identified with this variant, the report will not be variant of uncertain significance, no, it will be pathogenic. And it has outcome. This has major consequences. So I think this is one way to improve it, but it won't solve all our problems. So we also have the project that was on my initial title, the Gray Zone project. And this is a pilot that is funded by ALD Connect. Please, next. And there we more or less do the same. So if a variant is identified, what often happens is that these families go to massive screening. And once they contact me, they tell me, oh yeah, my uncle has the same variant and grandfather has the same variant. And in ALD we say, well, if you have a pathogenic variant, you should have elevated variant chain fatty acids, and eventually you should develop clinical signs and symptoms. So the plan is, and the goal is, to have these adult males being seen by an ALD specialist, to do a clinical assessment. So is there spinal cord involvement? Is there adrenal insufficiency? Do an MRI. So then we get a real good clinical assessment, take a sample, and then these samples are sent to Amsterdam. Because in Amsterdam we have a lot of experience. It can also go to Kennedy Krieger, but we need to work on this because it's also probably logistically more simple. But in Amsterdam we have established control range for over 200 patients, as you can see here, and over 1,200 healthy controls from all different ages. So if we repeat that, we can say something more about the biochemistry. Next, please. Optional, we can also investigate fibroblasts. We do functional studies. And the next, please. But of course, this is very scary because you base it on one individual. You say, okay, if you have now 5 males that are in their 70s or 60s, and they're all assessed by clinicians, and they really have no clinical problems, is that then maybe not a non-pathogenic variant or a mild variant? And if we have enough proof from one variant, I think that will help. You may wonder if the chance of getting cerebral ALD is that still possible. And I know we all think there's no correlation between biochemistry and clinical stuff, but this presentation is maybe like a few months too early because our research is showing that there is. There is a threshold in lyso-PC, and we hope to show that data next time. But and on top of that, we can also do lipidomics. So we look at over 10,000 lipids that some of them include ferro chain fatty acids, and in ALD patients these are really increased. So we're going to set out an ALD fingerprint lipidome by screening all these adults and many controls, and then we have cutoff levels. And it's all, the aim is to get more information of these vessels, to help these families. And I think, so what do we expect to find? I think we will find variants that we will conclude that these are likely benign. We will not go to benign because we really need a lot of proof, but likely benign. And I'm also sure that we will find variants that only result in late onset or mild symptoms. And in the past, these may have been overlooked because these individuals may have had such mild symptoms that they never ended up at an ALD specialist, and their ABCD1 gene was never screened. So, as in many diseases, the clinical spectrum will expand, and particularly on the mild side. And then you can question, should we pick up these variants? Do these individuals benefit from having a diagnosed ALD or extreme late onset DNA? And I think that will be a discussion in the coming years. And one more slide. And so this is, Elise, you also mentioned it already. Part of this work started at the ALD Alliance, where we collaborate with Joe Orsini, the head of the screening lab that made all this start in November, in 2013. And I had often heard Joe spoke about the harmonization project, and this is what it is. So we need to generate a lot of information, share information on screening, on cutoff levels, and I think the goal is eventually that we have to raise our cutoff levels, so that we only pick up boys, girls that benefit from early diagnosis. So I think in this, a lot of projects come together, and I think then this is what AOD Connect is putting on social media, and so there are 3 items, and we got a lot of families that fulfill this criteria. So if your baby was diagnosed with adrenoleukodystrophy via newborn screening, if the result that people receive from Invitae of the other companies is variant of uncertain significance, and if the family has no history of ALD, this is a gray zone. Because we don't know, is this ALD or is it no ALD? I think now my last slide. And yeah, the acknowledgement, this is really a community project. Worldwide, we have to work together. And of course, because there's so many states in the United States working on this, we see this particularly here. So ALD Connect, the ULF, and of course the ALD Alliance are part of this. And I reached this team in Amsterdam, and I hope we eventually move more and more to Europe, and then Ela will become part of this, and Lisa. Yeah, because I think this is a growing problem that we really have to solve. Because ALD newborn screening saves lives, but we should not create patients, because they don't benefit from it. So there's room for improvement. And with that, I thank you.
Thanks, Stefan, and I'll hand the mic to maybe Patty. You can help if there are questions.
have a question. So the variance of unknown significance in those functional essays that you said you can do in the cells of the patient, do you have that correlation between the very long chain fatty acid levels, that threshold that you were talking about, and the functionality of the cells? Like kind of, we instead of a picture of the doctor with the patient, which is what we really need to conclude, how close does the cell, not the patient, gets you to the threshold?
That's a very good question. What we do see with some of these variants is that if we do functional tests and we put the activity of a control cell at 100, then really ALD cells are at 20, 25%. And some of these VUSs are at 50 or 60%. I think it may not lead to disease, but we don't know. In mitochondrial diseases, I can only think of other examples, like in mitochondrial diseases. For some of these diseases, if you have 20% residual activity, one gets sick. So why would that be different in ALD? The only problem is that we don't know where that level is, because there's just a limited amount of data. We started very enthusiastic with the fibrillast tests, but I think it was too good. So we're now fine-tuning it, so lowering the concentrations of substrate we had. But I think the answer will probably come more from the lipidomics and the lyso-PC measurements.
Another question is, I know your guys are starting with the males and males that have relatives that are older. Do you want samples from, even if you're not going to be able to process them right now, would you be interested in samples of the same family? So there's background genes, the 99.9 that we are like, but like the females, the males, and maybe what it will be known to not have ABCD1. Are you interested in collecting this? I'm asking because we have the community in this meeting.
Yeah, I think it's an excellent point, and I think the answer is yes. Because this is the same as in the old days. If the result is really high, it's a positive result. If it's normal, we should take into account it's a female, the 2 X chromosomes, we don't know the X activation pattern, and we also have a few females in the clinic that are sisters of others, and they have the variant. We know it's a pathogenic variant, but their lyso-PC is normal, and we looked at the X chromosome inactivation, and they were really skewed to the normal allele. So there's an explanation. So in case, yeah, I think it's really important to also include women, but the interpretation is less clear.
At the moment.
Yeah.
Excellent.
Such exciting work, Stefan, and you know, I can't wait to see the expansion of the lipidomics into you know, various different chain lengths. At the same time, I'm a little worried about us defining answers, because I think actually what will happen over time is that we're always going to deal with uncertainty.
Yep.
And we should probably think more about risk stratification rather than, you know, tell people that we're going to, you know, have the answers in the future, right? Because this is, as you know,
Yep.
just continuing to evolve, and we'll always be making 2 steps forward and 1 step back, and we might have something that we think is definitive, and then we'll have to retract that again as we learn more. But I think, you know, together as a community, we're going to learn. I just think managing expectations, you know, of providers moving forward is key. So, yeah.
It's absolutely true. Yeah, we can only provide additional information. We will never say, okay, this is pathogenic, because without clinical proof, you can never make that assessment. So at best, it's a variant of uncertain significance that's never been showed with disease, but it does have an effect on the fatty acids. I don't think we can go any further than that. But I think you also mentioned expectations now, when I presented, or yeah. So yeah, we will not get the answer. But yeah, the answer comes from the first I showed, the collaboration with the clinicians. Like you mentioned yesterday to me that you have this whole list of variants. Yeah, that's where the answers are. And said the same. So that's where the part 1. And I think that's the most important one. And that the database can help.
Hi, I'm Kathy Zakowski. I have a question. Are you, in this database, will you be considering epigenetic factors or other environmental factors that could contribute?
No, the ALD database is just, it started together with Hugo Moser in 1999, just a dull collection of variants. And I scanned the literature and I am in contact, but no, it's just ABCD1. And there's not even clinical interpretation there because, yeah, we always said, well, there is no correlation. So it just said cases. And the case is somebody with clinical symptoms, a variant, and elevated levels.
Good morning, everybody. So the next talks are all exciting about new therapeutic interventions. Before we get to that, we have to get to the more boring stuff about the tools you need to actually evaluate those interventions, and those are outcome measures, and I was going to briefly talk about that. So I'm not going into ALD in detail, everybody will know that, but in adults, the main symptoms that people are experiencing daily life are symptoms of the spinal cord called myelopathy. And diseases of the spinal cord, they cause problems with motor function. In ALD, that's always limited to the lower limb, so with gait, with continence and pain. So these are the problems that people experience in daily life. And we're going to zoom in a little bit. Can I have the next slide, please? So what causes the gait disorder in ALD specifically? Well, you can look at the spinal cord as a big cable that connects the brain to, for instance, the muscles and the different sensors that we have. And the spinal cord is a thick cable that carries bundles of small fibers, and those are called tracts. And the unusual thing is that several genetic disorders affect those specific fiber tracts in a very distinct way. Same thing for ALD. So there's a couple of cables, if you will, that are primarily affected. And that's the blue one, the dorsal columns. And the dorsal columns are responsible for transferring information about position, sense, and movement to the brain. And if that cable is dysfunctional, then you have a problem with the input system. So your brain does not get the inputs about when you're moving and makes it more difficult to adjust when you walk. And the problem you get then is a disorder of balance and a disorder of coordination. That's called sensory ataxia. That's one thing. The other tract that's affected is called the corticospinal tract. So it's the red tract, and that is the output system. So you use it to control your muscles. And if that tract becomes dysfunctional, your muscles become stiff, unresponsive, discoordinated, and eventually also weak. And that complex of symptoms is called spasticity, and the combination is what affects the lower limbs in people with ALD and causes the gait disorder. So this is what most people will experience. Can I have the next slide? And as you know, those symptoms are not present at birth. People are completely healthy at birth. And it's a very slow process because it takes a very long time, decades, before the cables become so damaged that people experience problems in daily life. And as you can see in this curve, it's very rare to have symptoms of spinal cord disease in men before the age of 20. And progressively, once you get older, it's much more likely that you are affected. And if you're over 60, well, it's very, very unlikely that you will not be affected. And for women, it's kind of similar, just that onset is usually later. What I would like to add, this just means that you're affected, but it does not mean that you're severely affected. So you can have spinal cord disease and still experience very little problems in daily life. So it seems here that the women are just as severely affected as men. That is possible, but usually the progression in women is much slower. So you can say yes, at over 60 most women are affected, but it does not mean that most are severely impaired in their daily lives. Yeah, if you look at the bars, if you look at them very carefully, that we estimate about 90% of women, yeah, are affected when they're over 60. Yeah. All right. Can I have the next slide? So, how does the gait disorder evolve? Well, of course, you go from asymptomatic, and it gets progressively worse. And at first, if you have people in follow-up, you can see subtle things at neurological examination. For instance, the dorsal column is very easy to test functionally with a tuning fork. And you notice that people sometimes don't feel the tuning fork as well as they should, long before they actually have impairment in daily life. And then it slowly progresses over many decades from no signs and symptoms to eventually severe gait impairment. So this is very slow, which is a good thing, but not so much for clinical trials. So how, this disease progression, how do you determine that? Well, of course, for routine care, it's not difficult. You can ask people. You can ask people what problems they have in daily life. They can tell you. But if you want to do a study, if you want to evaluate a drug or something else, you need a number. You need to measure it. You need to quantify it. And that is the science of clinimetry, the tools to measure and quantify disease severity. It's not spectacular, but still, as you will see, pretty important. And I keep saying that, and it's still not changed. We're not really good at it, unfortunately. Next. So, first thing you have to determine what part of the disease do I want to quantify. And for ALD, well, for spinal cord disease, these are the categories you'd probably want to quantify. The gait, continence, maybe something else. And I think it's important to realize what I quantify, will that actually affect people in their daily life? And is there a meaningful, easy, practical way to actually measure it? Can I have the next slide? Yeah. So, to see how it's been done for the past couple of decades. For instance, for ALD, traditionally, for gait, people look at the 6-minute walk test. And it is almost as simple as you think. Basically, you need some room, and you need a stopwatch, and then you can determine how far somebody can walk in 6 minutes. Of course, in real life, if you want meaningful data, you have to be a little bit more precise than that and try to standardize it. But that is basically what it is. Can I have the next slide? Yeah, another tool that has been used since the early 1980s is the so-called EDSS, the Expanded Disability Status Scale. And the EDSS is nothing, it's nothing special. It's a neurological examination that is done very structured and in which there are some severity grading going on. And it ranges from 0 to 10. And it gives you some idea how impaired somebody is, for instance, in gait. And also you can use this, for instance, in ALD and in many other disorders. Next slide. But now the problem. If you use these tools, you can quantify the gait disorder. You can quantify it. You can also see progression over time, although a lot of time. And to put a number on it, say you have a new drug that you think is effective in slowing the spinal cord disease, and you want to test it, and you're going to test it with the 6-minute walk test. Then if you assume that your intervention can slow down the progression by 50%, which would be good, then you would need more than 450 patients in your group. And okay, we know that ALD is not that rare, but that is difficult. And for the EDSS, the problem is the same. So what's the problem with outcome measures? Yeah, I put an animation in it, so I think you can click 2 times. Yeah, thanks. Now it's complete. Yeah. So these outcome measures that we mentioned, they have problems. And they're not specific. So the 6-minute walk test is used for any disorder that affects walking. So it's not specific. And that is the problem. For instance, if you have a very poor cardiovascular condition, you will do poor on the 6-minute walk test. However, that does not in any way relate to your ALD. That does not measure the spinal cord disease. It measures something else. So that's a confounder. It's not really sensitive to small changes because we see that it hardly changes over 2 years. So that means that your trials will have to be very, very long. And also, it has a ceiling effect. So if you're very healthy and you have minor signs and symptoms, you will score very high on the 6-minute walk test. And 2 years later, you will fortunately still score very high. Did your disease progress? Yes. Can we measure it? No. So that means that if you want to do a trial, you have to exclude patients that are doing too well. And at the other side, a 6-minute walk test, it's all in the term, you have to be able to walk to administer it. So people that are more severely affected and might also want to join the trial cannot. So you lose people that will not be eligible. You only have the middle group, which is unpleasant if people want to contribute to the project, and it's also a problem if you have very few patients to start with. So we need new measures that better measure specifically the disorder we're interested in. For instance, the specific tracts in the spinal cord, because then they would not so be influenced by, confounding factors. And ideally also easy, cheap, fast. You want them to be sensitive to very small changes, so your trials can be short. And you would like to avoid the floor and ceiling effect, so everybody is eligible. So that's a long list of desirable test characteristics. Next slide, yeah. And I wanted to talk about some things that will at least solve these problems a little bit. And I wanted to call them new ways, but that's actually not true, because the Kennedy Krieger Institute has been working on SWAY for now a very, very, very long time. And I think finally it might be moving forward a little bit. But there's also cool new technology, wearable sensors. Many people in the room have something that resembles it, smartwatches. But they're also available for research. You can stick a few on people and measure all kinds of things. And I would like to show you what could be the possible advantages. Can I have the next slide? So what's the great thing about body sway, and why was it actually a very good idea to use it specifically for ALD? We talked about the dorsal columns, and the dorsal columns are always affected in the spinal cord of ALD, people with ALD. And it is the input system. And everybody, when you stand, you wobble a little bit. But you correct that subconsciously, and you hardly notice it. When you have a problem with your spinal cord, you wobble a lot more. And that you can quantify with different techniques. You can do it with wearables, you can do it with the force plate. But this is interesting because you measure exactly what you want to measure, function of the spinal cord. And what we think and what we were able to show together with Kennedy Krieger the last period of time is that it's related to real life problems. People who wobble a lot, who have large sway, are much more likely to fall. And that means that what you're measuring is really relevant to somebody's well-being, and that you could justify making this an outcome measure. Can I have the next slide? So, and what's also attractive about it, it's easy. You put somebody on the big blue force plate there. It takes just a couple of minutes, and you can do it in different conditions. You can make it more difficult. You can put the feet together, you can close the eyes, that makes it more difficult. Or if people are very wobbly, then you can make it easier, eyes open, feet apart. So you lose very few people to the floor and ceiling effect. And what's also interesting is that you can identify people who are clinically asymptomatic do worse than controls. And, well, that we have to see. We hope also that it better captures changes over time. So we think that this could be something that in future trials, now usually it's, you will talk about it probably, Wolfgang, as a secondary outcome, but we think that it's ready to move up as the primary outcome. So it's a very usable thing. Next, please. Okay, well then, briefly, there are advantages of using wearable sensors. Of course, it's very easy. You can do your normal assessments, but you get your regular parameters. For instance, if you do a 6-minute walk test with these sensors, you get your regular walking distance, but you get all the additional information. You get walking speed, turning speeds, step size, everything. Another additional advantage for them is that if you live very far from the hospital, it can be mailed to you. You can do some assessments at home. Something that in our tiny, tiny country we are a little less interested in, but here that could be a big advantage. And next slide. I borrowed some slides from the people from Kennedy Krieger who actually made the graphs. First thing is what we were happy about is that the sway you can also do with the sensors, which is much more comfortable and easier, and you don't have to carry the enormous force plate around. And here also it correlated with the risk of falling. Can I have the next one? And just a random slide really. We think there's much more in this data set because people, for instance, who take smaller steps are also probably more affected and have a higher risk of falling. So there's lots of things in there that we could probably use to better quantify disease in the future. Can I have the next one? So we're not perfect yet, but I think that finally we can probably in the next few years say goodbye to the 6-minute walk test and things like that. It's still not perfect, but we're slowly getting there. And yeah, stay alert for new ideas and technological advances that we could apply to this problem. And what would really help, I think now, it's usually local efforts with small groups. I think we could speed this up tremendously if we had a very large consortium and if everybody would do the follow-up in exactly the same way. We could probably, make this happen faster, and if there's a new idea, we could probably implement it faster. And I think I only have one more slide probably, yeah? Yep, thanks. So I think I stayed within my allotted time slot, but if there's anybody with
Thanks, Mark.
Any questions?
Hi Mark. Yeah, I really like the sway. It's a very cool machine. So you showed now, I think, patients. But is there also already prospective data, that you follow-up data of patients that are on the sway plate every year? And
Yep.
Do you see it going in the direction where you think it's going?
Yes. No, we see changes over time. Not as, okay, so it's always, for us, we would like to see big changes over 1 year, because that would make therapeutic, that would make trials much more difficult. But we don't see that. It's still slow. Yeah, so you're not going to measure large difference over 1 year. Trials are still going to be 2 years. Yeah, but we see progression.
So do you think then that it's so sensitive that the number of the 226 that you showed with the 6-minute walk test?
It will go down.
Yeah.
It will go down. Also because you have less confounders like uncomfortable shoes, painful toes.
Yeah.
The spread is much less. The data will be better, but it's not going to be 10 and it's not going to be 1 year. No.
Thanks.
Mark, you talk about having this systematically assessed on the patients that come for clinical care and through large consortium.
Mm-hmm.
How do you implement this on a GLIA consortium? There is, in the US, a leukodystrophy consortium, ALD patients are being evaluated in multiple places. Yeah. What do you think it takes, like cost, resources, any IRB changes or anything? Can you elaborate what you think could happen if we wanted to put it in GLIA?
Well, it's something that we've all been talking about. I'm open to suggestions how to do it. Now, the thing is, it takes time. And if in routine clinical practice, you don't have 3 hours to evaluate something, it's not going to happen. So we have to find a way to get more data from routine visits. Yeah.
Follow-up question to see if we could ever justify it to be covered by the standard of care. Would you change management if you find a sway to be worsening in terms of preventing falls or sessions of physical therapy, maybe? Looking over there.
Again,
because if that's something that we show is the case, then this should be part of the assessment. Like you just said it at the very beginning, this is part of the pathomechanisms. Like these tracks are affected. It's a much more sensitive way to predict risk. Like talking to what Florian was saying, like risk stratification. Could we use it? Yep. And if that is published, should we be doing it and indicating it? I don't know if you want.
No, it's open to suggestions.
You have.
I think it's related to what you all are saying. So in MS, in multiple sclerosis, there's a lot of work being done in this idea of a prodromal period. So a period before you have a lot of you have the diagnosis, but you don't have a lot of clinical symptoms. So I'm wondering, is there any benefit? I hear you that physicians don't, sorry, is that me? That physicians don't have as time to do all these clinical outcomes, right? But what if there was a way to establish that everyone wore a wearable, and even just step counts and, something related to general activity could give us some information to start with, as like as a way of tracking people and getting more data than once a year or even once every 6 months, which I think is part of the problem, right? It's a rare disease, and then we have few data points because we can't get people, into a clinic where physicians have time to collect all of this. So is that a way to sort of get around that? Sorry.
Yeah, maybe. Yeah, that also sounds interesting. But for me, there's still a clear distinction between research and routine care. And maybe they can get closer together once these technologies evolve. And like what you said, if they can really predict risk of falls and injury, then you could probably justify making it part of routine care. But for now, I think it's really separate worlds.
Yeah. Because even our way of measuring falls is not very accurate, right? Because it's still, did you fall? As a basically, right?
Yeah, but the great thing is with the technological tools we have now, the electronic data capture systems, they automatically badger people.
That's good. Okay, so that's, because
so
I feel like that's what we need to kind of
all
work
the
toward.
time, so you have a lot of missing data, but you get such a massive data pool that you can still work with it.
Yeah. Okay, thank you.
I see a question over here. And for everybody asking a question, please say your name and where you're from.
Hi, Jen Orthman from University of Pennsylvania. Thanks for this really cool talk, imagining how to incorporate it into what I do. Is there data showing a difference for people that have started using a walking aid for the sway test, and does it improve it, or is that like a threshold for when people might need it or something like that? Because I guess what you presented was that it was an early detector, but not necessarily how to incorporate the people that aren't able to stand there for a while. Or
Yeah, no, it's okay. I'm not sure if the walking aid is like EDSS-6, right? And in the data set, you do see that EDS6 is kind of a cutoff for high risk of falling. But the sway test we always do without an aid, so you have to stand unsupported. So you're right, it still has a kind of the more severely affected people you cannot evaluate this way.
but can you do it with it?
Whew, never thought about it. Yeah.
I'm Brian Wisher. I'm physiatrist at MGH. So I think the challenge with doing it with it is the amount of force that you're adding on with just adding a cane in is like sixfold in terms of like how much support you're giving. So you're going to change. It's going to be so dramatically improved that it probably isn't going to be all that valuable in a real life situation if they're just holding it there.
But it's a nice idea.
Yeah, I had one question. I mean, we talk all about these wearables and all that. I mean, we have gait motion analysis studies and that stuff, and I feel like we don't utilize them from a research basis all that much. And
Yeah, you're right. And
they put in so much information, and I think it would give a lot here, even if it was once every other year. If when you're seeing, having this kind of more
No, you're right. We've never been able to get enough access to those facilities. Yeah, it's complicated. It takes a lot of time. So you're right. Of course, the real motion labs are better, but just too impractical and expensive. And so we're hoping this is kind of the next best thing. Yeah, but yeah.
I feel like we're doing something.
No, those motion labs, they have fantastic things. I mean, even, moving platforms and all kinds of really cool things. But, yeah, the implementation is difficult.
Mark, I also think that sway is an important outcome. I'm very much in favor of this. But it's not all, because the disease is much more complex than just looking at sway. Just to remind you of the cognitive symptoms that may occur, there are bladder dysfunction that may occur over time. So I just want to remind you that there is a disease-specific score which is all including SWAY, which is used and which is able to quantify in a disease-specific way the progression of ALD, all variants of ALD, not only AMN, but also adult cerebral patients. So yes, we need some clinical usable screening tests, and for example, the ALD clinical score, you can use that in 10 minutes or 15 minutes. So this is also something that should be included, I think.
Maybe we should use it more. Yeah, that's true. But you know, I think it's kind of complementary. The LD score, it has its uses, but again, it's not very sensitive. It measures kind of large declines. So it's one thing. Of course, we have to look at multiple measures, but I think we also need something really quantifiable. Yeah.
Hi everyone. First of all, apologies. Eileen, my colleague, she wasn't able to come here and she tried to do the presentation online. And as you know, sometimes we have technical issues, so I will happy to present in her behalf. I'm Chris Pasalacqua. I'm a clinician, a clinical geneticist, and I started working for SWAN recently. So I will try to do my best, and I want to thank you, the organizer, because this has been an amazing conference. I learned a lot, and also I love the interaction between patient advocacy, and also the clinician and the people working in these diseases. I'm also, as a disclaimer, of course, I'm a full employee for SWAN Bio. So the previous one, please. So SWAN is a new-age entity. We are starting in 2018 and was based in a really strong science that was this need to translate from preclinical studies to move ahead to clinical. And it's really important there was a really deep knowledge in the disease, and also what is the best technique to translate preclinical models to go into humans. And there was a lot of research and effort to bring this technology. Next one. So as we see in the previous presentations, there are different methods to use a gene therapy. In our case, we're using AAV that is being proved safe. And it's really important because given the characteristic that different serotypes or different envelope to transmit this information, and those can be used in different ways. In our case, we use AAV9 that has been used in the past, not only in AMN, but also in other disorders to be a right candidate to deliver information to the CNS. And the goal is to produce a one-time delivery that will still producing and improve clinical symptoms through years. So as we saw in previous presentation, this is a capsid that at the end doesn't contain any viral particles that are going to be infected. So this is really important. This is just a vehicle that we're using, and the virus is designed to go where we want to go, in this case, CNS, and we have a promoter to let them know the cells that need to start producing what we want. In this case, a new healthy copy of the ABCD1 gene. Next. And we are fortunate that in this particular case, AAV9 is not the first time used in humans. There are full studies and there are gene therapies approved using AAV9. So the perfect safety profile is better. We know I'm collecting every, I'm collecting every year, perfect. A little off, but we're collecting every year more safety data, and efficacy will be easier to understand in the future. And that's really important because when we have an adverse event, then of course we don't want to see it, but happen in clinical studies, when you have past experience with other programs, you can extrapolate and try to discern if this is related to gene therapy, or is related to the disease, or is something new. So it's really important, as we mentioned before, do a collaborative studies, done everybody from research, pharma, patient advocacy, share this information, and we can understand better how work gene therapies. We have currently 3 therapies approved in AAV, and we can see the deliveries and also organ tissues that have been successful, because this is really important where we want to target, and need to be a balance of efficacy. We need the gene therapy to work, but also not go as much in other organs than we can see adverse events. Next one. So why we are using AAV for AMN? Because we have a deep, strong knowledge about the science and the background of the disease. Again, we're seeing other presentation that not only affect this, but also can affect other parts of the body. So it's important that we need to have some limitation and understanding where we're gonna see an effect, and there is not one therapy for all the symptoms. And that's really important, that we need to understand that gene therapy is gonna be a potential help, but it's not meant to be a cure for all the symptoms in AMN. And that's really unfortunate, but we're working on it. And AAV has been, as I said, proved safe in other diseases and have a really good target to go to the CNS and to, from the cerebral fluid, go to the axon and neurons. And they're still producing the healthy copy of the protein. Next one. So as I mentioned before, we're using AAV9 because it's been a really good candidate to carry our information as like an Uber driver, go directly to where we need to start producing the healthy copy. Next one. This is important. How is the procedure done? It's an intrathecal infusion, so it's a little a procedure that needs to happen. And it takes some time to deliver in humans because we want that it's going really slowly release these all millions of copies of viruses to the CSF and don't go to distribute to the rest of the CNS. It's important for us that they don't need to be in this decreased position. We hope that the people going to the therapy start walking because they own the ambulation and improve the circulation of the CSF, and that will improve better the impregnation in the neurons. Next one. And before we go into clinic, of course, we need to have animal models. As you know, in AMN, there's some animal models. They're not perfect, of course, but they give us some highlights that the therapy could work and how we can see if it's working. Of course, we need to see effect of the VLCFA. It does need to go decreasing, and we're seeing that. And dose-related matter, and we see on the left that different doses, of course, untreated first, wild type, and then we see in higher doses go down. I want to mention also that the doses in AAV depend on your delivery. When we see in internet and publication that they see higher doses that are related to adverse events in other diseases, is because when you do intravenous for the full body of AAV, you need a lot of virus load, and you need several copies. When you do intrathecal, or for example to the eye, you need lower copies because you're really targeting a zone of the body, and that is really helpful for the safety profile of our therapy. Then we move to the right, and we can see animal studies with mouses affecting with a model of the disease, and we see trends are improving the functional improvement. For example, the grip strength, how much the mice can hold in a grid, and that is improving in a dose-dependent manner. And it's important translate also for non-human primates to see safety profile and toxicological profile, and that is being safe, and we see some transient elevation of the liver, and those are resolved continuously. And this is really important because not only in this therapy, but in most of the gene therapies, the liver sometimes is affected as adverse reaction, and it's really important to monitor that. And also in humans, we use therapies for decrease the immune response to this therapy. So we try to give a balance that not overdo it, but at the same time decrease the risk of adverse events. Next one. So this is really good that we have the presentation with our previous colleague before about the endpoints, because it's a really challenging AMN. We understand the progression of the disease, but we don't have a full picture how this progress and how we can get this natural history data to get better endpoints. And we understand the challenges for the 6-minute walking test, and we understand that it's not perfect, and we need to find better solutions. So that's why we're doing 2 studies. First, we start with the natural history for see the evaluation and not only using clinical endpoint, but also wearable technology to try to see correlations. And with that information, have better understanding now than we start PROPEL, or clinical study, and men with AMN, and see how we can merge this data to have a better understanding when we move ahead, and hopefully with a good safety profile, have interaction with the regulators and design our pivotal study. So this involves a clinical visit, using of wearables, and remote visits because we understand the challenges to go to a center, especially traveling, to have a clinical study. So we're trying to do a balance to get good data, but at the same time, keeping the quality of life of people who really engage and give us their time to participate in the studies. Next one. As we described before, it's really challenging to have this balance between be a really inclusive study, but at the same time find this kind of sweet spot that we're gonna see changes through time. And fortunately, the disease, most of the cases progress really slowly, so it will be really challenging to see changes in a short period of time. So as we see on the right, the ADS scale, we see that SIGNET, the natural history study, have a broader inclusion-exclusion criteria because we want to have a bigger picture how the disease progress in people who are really not affected or, unfortunately, more severely affected. But PROPEL, the clinical study, we're restricting this to have this kind of sweet spot, hopefully, than people who have already some symptoms, but it's not progressing as fast yet. We're also excluding people who have evidence or history of cerebral inflammatory disease because those people, unfortunately, are more affected and will sway this equation of how we can measure endpoints in a clinical study. And you can see more information, of course, in clinicaltrials.bio or clinicaltrials.gov, that is information publicly available. Next one. Perfect. So we're really happy to inform that the SIGNET, the natural history study, the enrollment is complete. We're following these people, and we really appreciate the patients and also the centers that are collaborating in this study. It's a multinational study, and the goal is have 65 patients around the world. Then we're trying to see how they progress and trying to measure between the clinical endpoints, questionnaires, and also wearables to see how this disease progress and try to correlate in the future for PROPEL. And of course, there was a try to COVID, and we try to really be flexible in improving the quality of life and not be that bothering with these studies. So there we have a lot of in-clinic visits, but also remote. Next one. So we have already some baseline data, and we're really excited to collect. As we mentioned in other talks, there's a lot of information that you can get from wearables. So then you need to clean this data and try to see some trends. We can see the distribution to ADSCs to see like the severity of the people enrolling in this study. We can see that around 25% need some walking aid, but we have a good distribution around people who may be eligible for moving from the SIGNET, the natural history study, to PROPEL, the clinical study. We can see on the right also that we were concerned how good is going to be the correlation between the clinical assessment doing in the hospital versus the use of the wearables, and we see a strong correlation. And that's really important because we need to think in the future that trying to be a more friendly study, and wearables can give us real data. We have like the kind of white coat effect that we're not doing in the clinic, they are doing at home, and see if we can correlate those studies. Next one. And this is a little high level of PROPEL. You can see more information in clinicaltrials.gov. But the goal is just to have like a single administration intrathecally and then a long-term follow-up, because we need to have a follow-up for efficacy, but also more important for safety and a long-term. And the study is based on, we're going to start with a low-dose group that we already started. We do a safety evaluation, and then if we have an external from a DSMB, so we have external physicians that see our safety data, and they discuss with us as the sponsor, and we move ahead to the higher dose, and from then we have another discussion, and then decide what is going to be the dose and the rest of the people are going to participate in the study. And this data is really important as a safety profile, but also some trends of efficacy that then we can discuss based also with our data from SIGNET, the natural history, how we can develop the best phase 3 and a study. Next one. And again, I will be happy to answer as much of the question I can, and thank you so much for your participation and for the interest in this talk.
Are there any questions?
Do you expect improvements?
Oh, great question.
Could
does
you repeat the question for the online people?
Sure. That was the million-dollar question, if we can expect to see improvement. The animal data is quite positive, then we see some trends, for example, in the grip effect, so that will give us some hope. It's important to set the expectation, as we mentioned before, that we have some hope in the improve the motor symptoms of the disease, but the disease, of course, affects different parts of the body. And it's going to be really important to see the natural history data, how the people with AMN progress on time, and since it's a really slowly decrease. Best case scenario will be improvement. More middle ground will be a slow deterioration of the disease. So we need to also set the expectation that not only in our therapy, but in most of these gene therapies, in a slowly progressive disease, you need to have a balance that what is the expectation, and as you mentioned before, and the other coordination, what is your change that you can see in this endpoint, because these endpoints are really not perfect, and they have a lot of variability, and you can perform better or worse, for example, in a 6-minute walking test, so it's going to be also challenging for a sample size, how you can measure this improvement. So it's going to be, I think, a combination of the classical endpoints, wearables, and as you mentioned, also the quality of life or other questionnaire to see how the people feel to this therapy. So it's going to be really interesting collecting this data, and also support for the natural history study and also other databases.
I have a question that is related to, you talk about AAV9 is the one that is in clinic. You show us there's so many different trials. How is this therapy expected to target the cells that you want and not target the cells that you don't want, to not have to deal with side effects or toxicity from expressing a little bit too much of ABCD1?
Yeah, that's a great question. We have some animal data that, for example, here in the disease, we need to have some DRG effect. So in this case, for our study, it's positive, and we have a positive expression there, and also we see low expression in other organs in the animal models. For example, heart or liver or other organs. And as you mentioned, it's a good balance that we see expression in neurons, and we see to animal model expression there, and not see that much in others. The advantage of AAVs also in general, that they are not replicated as lentiviruses, so we are not expecting to have like a potential transmission into the next generation, or the oncogenesis is really low. It's not zero, as we know, then there's more studies, so that is a potential risk that we need to follow up 2 years. But in our case, we are seeing a good data of expression in the cells that we want, and not much adverse events in the others. So for so far in animal models, we have a really good safety profile.
Excellent. Any other questions? Thank you so much.
Thank you so much, and apologies again.
Well, controlled clinical trials is a big challenge in rare disease. This is true for all rare disease, because you have not enough people to participate in such long controlled trials. But on the other hand side, it's still, even in rare diseases, it's the gold standard. So everybody is asking, do you have a controlled trial? So we are really happy that for the first time you are successful to have an international cooperation, and this is the only way to have such controlled trials in a certain treatment, in this case a drug called lariclitazone, which was tested in adrenomyeloneuropathy in a double-blind, randomized fashion over 2 years. You see here the plan. There's a screening phase, there's the double-blind treatment, and currently there is an open extension follow-up treatment for all patients who are involved in this clinical study. And this is the first thing that we can learn from this effort, that it is possible, if many centers really work together, it is possible to have this information in terms of a controlled clinical trial. So 116 patients are randomized either to get the placebo and or the leroglitazone treatment in these centers that you can see here. There are 3 centers in the US. There are centers in the UK, in Netherlands, in Hungary, France, Italy, Spain, and Germany. So, so this was the plan. You can ask, of course, why? What was leroglitazone? Why do we use this drug? Can I have the next slide? Well, there are some. This is maybe too complicated, but what you can see from this slide, there is some information from preclinical studies in animals or in the dish, showing that if you look at these columns here, that inflammation is affected going down with this treatment. That there is in other construct, in this case an animal construct, then you see improvement of motor functions. For example, if you see the videos from the mice treated with this before and after, before they had the AMN and after they're working perfectly. So it's an improvement in the mice. So it's very impressive from this preclinical data. And people say, wow, let's try this in humans as well. And there are other very interesting effects that are coming up. For example, there's an improvement of myelination. You see the columns go up. And there's a decrease of inflammatory reactions in the brain, looking at microglia, which is a brain immune cell, from this treatment. So the proof of concept and the preclinical data are very impressive. So this is why people say, well, let's invest in this clinical trial, and the investment is a multi-billion-dollar thing. And let's have this this international cooperation to find out if this treatment is really helpful in humans as well, not only in the animals. So this is the second thing that we have to learn. We not only need an international cooperation to get some new information about new treatments, we also need a lot of money. So, next. So this is summarizing the effects of leroglitazone. There is an obvious effect on neuroinflammation, which is helpful probably. There's an effect on remyelination, potentially, that is helpful. There's an effect of the axonal degeneration, and there's an effect on oxidative stress and mitochondrial dysfunctions. And all these effects are measured in preclinical studies, showing that it probably makes sense to use this treatment in humans as well. So then, of course, the second question is, what can we learn in terms of outcome measures? We already discussed a lot today and about the outcome measures. And I was, from the beginning on, I personally was really unhappy about the 6-minute walking test as being the primary outcome measure in this study. But there was no way that we can change this, because the authorities were really convinced that we have to use the 6-minute walking test. So this is something we should keep in mind, that we had to use an outcome measure, which we all know that is not the best outcome measure, but as we already discussed previously today. So there are other outcome measures which are secondary. They are listed here. For example, the outcome measure balance, which is much more important, at least for many patients, for their everyday life. I also want to remember that looking at 6-minute walking test, I mean, this is obviously a good outcome measure for people who are very mildly affected because they want to walk, they want to improve their walking because they're highly motivated to improve their walking. So this is a good outcome measure for early phases of the disease, obviously. But when it goes further in the disease progress and you're sitting in the wheelchair most of the time, but you're still able to walk maybe, but it's very, it's very disturbing, it's very difficult to walk at all. So you are not motivated to walk at all. So this is not a good outcome measure for late phases of the disease because nobody wants to walk. So they are not motivated that it should change anything. So we had all these outcome measures, and it's important. It's important to know if you're looking at these control trials, you have to predefine all these outcome measures. You cannot say, let's say what we get, and then we look at what is what is the best outcome, and then say, okay, there's a good outcome there, there, and there. So we have to predefine these outcome measures. And in this case, in this study, we have to predefine the outcome measure 6-minute walking test. So if this 6-minute walking test fails, I'm formally also not allowed to look at the secondary outcome measures. So we have to keep this in mind when we look at the results of this study. That's it, next. This is just to remind you that in the study we also measured the sway that we already discussed, and we also think that sway is an emerging objective outcome measure which is not used as the primary outcome in the study but a secondary outcome. Next. So now what can we learn from the results? First, looking at this graph here, what you see is these are the results from the placebo patients. This is 6-minute walking test. So you can see the 6-minute walking test in the placebo patients is getting worse, but in the patients with the liraglutide, it's not as worse, but this is not a significant difference. So the primary outcome measure, 6-minute walking test, looking at all patients was no difference between placebo and liraglutide. This is one point. If you look at various stages of the disease, patients who are ill for 20 years, for 15 years, for 10 years, or 5 years, and looking how is the outcome measure using the liraglutide, there's no big difference in the liraglutide. So you can say probably if you just look at the numbers, then you can see that using liraglutide over 2 years, all patients seems to be completely stable. There's no big deterioration over time. Next, please. But compared to placebo, there's big differences in early phases of the disease versus late phases of the disease. You can see here that the placebo patients in early phases of the disease, no longer diseased than 5 years, are really getting worse compared to the liraglutide patients. So this implicates a little bit that there's probably a stage-dependent axonal protection with this treatment. This is not predefined, but these are data that you can discuss about. It looks like that if you use the drug in early phases of the disease, that makes a big difference if you use it in late phases of the disease, it doesn't make any difference anymore. So early treatment seems to be a possible effect of this treatment. A second thing that we learned from this study is that we noticed that patients with placebo get the cerebral involvement in the 2-year period. There were 6 patients who get the cerebral ALD. 6 out of 33 patients get the cerebral involvement in a 2-year period. That's a lot. And there was no patient with larotrectinone getting cerebral involvement in the same period of time. So this is an interesting, very interesting observation, which may be highly relevant for patients. Getting the cerebral inflammation from AMN to cerebral inflammation is life-threatening, as you all know. And this also implicates that new other treatments needs to be done, for example, stem cell transplantation, if this is possible at all, or gene therapy maybe in the future. So from this, you could, next, you could think that this treatment has a preventive effect of the cerebral inflammatory demyelination occurring in many of the patients without treatment. So this is very important point that comes out that we learned from this study as well. So in summary, I would say this is it's very important that it's possible at all, and this is the first controlled clinical trial in adrenal myeloneuropathy, so it is possible, but it's you have to work in an international cooperation, and of course you need a sponsor who is paying for this trial like this. We had in this trial, unfortunately, no effect on the primary endpoint, which is the 6-minute walking test. But there is some other effects that are very important, in my eyes at least. There are secondary outcome reports on an influence of sway, for example, and of course on the onset of cerebral involvement in the brain. So there are some positive treatment effects, and on the other hand side, this treatment is quite well tolerated. There are problems. I'm not talking too much right now because of the time for side effects, but I can, if you want, talk about this on a personal level. So, but there are especially MRI results that really favor the active treatment because only the patients in the placebo arm showed progression of inflammation or brain demyelination, and this is also true in the open label extension right now. So this is there are many positive effects which occur from this, what we learned from this treatment, that we probably but that at least we can hope that this treatment will be approved for treatment for AMN as well. So what are the consequences for this, for our current strategy in AMN from this treatment? Next, please. So this gives you a summary of what is our current therapeutic strategy in AMN and adulthood cerebral ALD, and what are the main findings, what is the background, and as you can see, and you all know that X-linked adrenoleukodystrophy is an inborn error of metabolism, so the normalization of long-chain fatty acids seems, at least for me, and it should also for you, be a basic treatment in all phenotypes. And in my eyes, normalization of long-chain fatty acids has some effect of pre-symptomatic patients. It has also some effect of already involved AMN patients in terms of slowing clinical progression. But this is not shown in a randomized controlled trial because this is simply not possible. By the way, I don't think that there will be a controlled clinical trial for dietary therapy ever. So this is an open question that will remain open even in the future. It's only a matter of logical thinking that normalization of long-chain fatty acids in a disease that has a metabolic defect is helpful, yes or no. So there were other treatments, for example, antioxidative treatments affecting the energy depletion with biotin, for example, or the Barcelona cocktail. They are not effective. Of course, we have a lot of symptomatic treatments that are very helpful to relieve symptoms like pain and spasticity, for example. And we have, of course, for the cerebral variants of the disease, we have the hematopoietic stem cell therapy, even in adulthood, showing that there is at least 70 to 80% long-term survival and completely stable cognition in at least 50% even in adulthood. So this is a treatment that is life-saving in patients with cerebral involvement. But as you see, there are still some unmet needs present. Next, please. That we should address. For example, the correction of the inborn error of metabolism is still an unmet need, I think. So there should be more information about the treatments with mono or polyunsaturated fatty acids or Rances oil, whatever. There are other treatments addressing the metabolic disease, and clinical trials are needed for these treatments that are upcoming probably. There's also some needs in addressing the mitochondrial oxidative stress in this disease. There is some data on DNAC, but there's a trial needed, a controlled trial to show that there is an effective, there's a benefit from these treatments. There is some data from larotrectinone that we can use that's available already against the oxidative stress. So this is a little bit of positive on the positive side. And you can see that this probably, I showed it again because this will probably cause the stage-dependent axonal protection. Of course, we need some strategies against the inflammation. We have the stem cell transplantation that prevents the progression into brain inflammation, and we have the data from larotrectinone that I showed you that also gives you the idea that larotrectinone can also reduce neuroinflammation and microglia activation, so preventing from cerebral involvement, as you can see here in the patients who are treated in green with larotrectinone who do not get cerebral involvement versus the placebo patients who get cerebral involvement. And there are other treatments coming up and need to be tested in clinical trials, but we have some information from the stem cell therapy and some information from the larotrectinone. And finally, well, of course, we need some treatments to remyelinate for the axonal repair, and that was my question. If there's an axonal repair with this new treatment, with the gene therapy, intrathecal gene therapy, with the AAV9 virus vector. So this is a great hope that this will also improve the treatment. So what lessons do we have learned? Well, there's results from preclinical experiments in mice that cannot be fully one-to-one transferred into humans. As you remember, I told you the mice are really perfectly improving their walking abilities, but this is not, unfortunately, not the case in the humans. But we need some more and better clinical outcome parameters to show clinical effects. But on the other hand side, what we learned from this study is that clinical control trials are possible even for rare diseases if we work together on an international level and if we have strong financial partners. But still further treatments are needed for the multiple unmet needs in ALD. For the lerokitasone, I think it's obviously a very promising drug, especially in early stages of the AMN progression. So we have to address this, maybe in further studies. It is potentially preventive from cerebral inflammation, from the conversion to cerebral inflammation, and this is already addressed in several studies that we're going to hear about in the next minutes, I think. There are further studies with lerokitasone ongoing. There's an open label extension, as I already said, for the AMN patients. There will be new studies for adult cerebral patients here in the US and in Americas, and for the adult cerebral patients. And there is a compassionate use data that we probably hear about today, and we can discuss this data as well. Thank you very much for the attention.
Hold on to it for questions. You can hold the mic.
You have questions? Yeah. Okay.
When do you think that glitazone would be approved out there? Tough question.
Well, we hope this year. Yeah? In Europe. At least in Europe. Yeah. Oh, he's my patient.
I like
Is it?
Yeah.
Yeah. More questions? Okay.
Wolfgang, one question here. What will be your expectation over treatment over 10 years with liraglutide? What do you think the cohort is going to look like? Like these patients have now, some of them have been on several years on liraglutide. Do you have an expectation? You talk about remyelination maybe happening, we don't know it. Do you have a sense of, by seeing the patients going into several years of treatment, what expectation these patients will have?
Well, my expectation will be that lerokitasone is not the only treatment in AMN, so we will have a combined treatment. That's my expectation. Lerokitasone is not affecting the metabolic situation, for example. So you will have to normalize the metabolic situation in addition to the treatment with lerokitasone, which is hopefully, that's my greatest hope, that this treatment is really preventing from cerebral inflammation. I'm not sure if it's really helpful in preventing the neurodegeneration, but it looks like that it is very helpful in early stages. So I would, if it is approved, I would recommend it to patients, to all patients, at least in early stages of the AMN disease. But this is not the only treatment that we need. We need other treatments. So my expectation is that we will have a combined treatment in AMN. Yeah.
So what is the plan for women on this drug?
Yeah. I think we hope that authorities will approve this drug for all kinds of AMN, and women do have AMN. So if they look at it very in a strict way, then say you've only tested men, so you will only approve it for men, then we have to give it off label. Yeah, I don't know what is the decision of the authorities on this, if they approve it at all, if they approve it only for men. We don't know. Aaron, do you have some idea?
Thank you. Aaron Mystery from Minarex, Chief Medical Officer. So it's a very good question, and the regulatory bodies, the FDA, EMA, always want data. I think that's the key thing. And as Dr. Englund has said, collecting the right data in the right trial design is fundamental to a successful outcome. So I think with the profile of how the data now looks with the natural history of AMN in women, it wouldn't be the same sort of trial potentially. We need to find an endpoint that really is more manageable over a shorter term, otherwise it's a very long trial which will take a long time to deliver data to the authorities. So I think more natural history data is needed, a better understanding of the disease in women, and that is one of the plans that we have as well, of understanding that in more of an imaging way as well as the clinical outcomes.
Excellent. We don't have any other questions. We'll move on. Thank you so much, Wolfgang. I'm Patty Mussolino. I'm a clinician and neurologist at MGH in Boston. And I'm going to be presenting an interim results of this trial that is Nexus is liraglutide, so we are following very nicely along, and I'm not going to spend too much time about what liraglutide is. And it's just the first 6 months of follow-up for the boys that have been treated with liraglutide in Europe. This study has 5 sites currently working in Europe. Enrollment finished in May this year with 23, wow, in 1 week, 23 patients. And there's going to be a follow-up where we're going to find the results of the trial at 2 years. That's going to be likely fall of 2025, so stay tuned. But we wanted to share what we are seeing in terms of what the lesions look like and what we are getting and not getting as an effect evaluated by the parameters that we have currently, mostly to open up to what is needed to really understand these very early lesions. And it's a really nice privilege to follow Elisa with the newborn screening work, because that's what has enabled this kind of studies to start occurring. And we still have a lot of questions. So next slide. And I'm the principal investigator for the Nexus trial. That's important disclosure. And I have done some research as well at the bench trying to understand. So we are kind of accustomed to hear about you're born, there is a lack of function of the ABCD1 gene. That's why your very long chain fatty acids, if you are a man, a boy, a male, are going to be elevated. And at birth, this is an MRI, like section this way. So head looking up, the feet towards you, and that has no lesion. So you can see the white matter is black, and it doesn't have any white patches. So that's what we call normal, and you heard the story, and you know it on your own families, that they are not affected. And that lack of function of the ABCD1, which codes for that protein in the peroxisome, which is inside the cell, leads to not have the metabolism that we're referring to kind of degrade these very long-chain fatty acids, and that's why you have high levels of that. And Stefan was talking about lyso-PC C26. That's what we are talking about with very long-chain fatty acids. Next, please. And the next one. And then sometime, and this is, I'm going to concentrate on the childhood form of cerebral inflammation and demyelination, cerebral ALD. I'm not going to refer to the adult because we're going to have Amina talking about the adult cerebral ALD presentations. So a common age for lesions to appear first on the MRI is around early childhood, 4 to 9 years of age. The recommendation is now we start screening with MRIs very early, year and a half, okay, to see every 6 months that you're in this group and not in the ones that have a lesion. And next. And the lesions characteristically at that age group progress, kind of like as if it was a wild forest, just contiguous to the next area. And the presence of this thing, which is a different sequence, the patch will be white here, but this white here is the gadolinium that was put in the vein of the patient. It should not go into the brain. It should look like this. Okay? So here we have leakage. And that is the inflammation, the inflammatory cells that are in the blood, the white blood cells that are coming into the brain. That's a marker of that disruption of blood-brain barrier. And we call it BBB, blood-brain barrier. That's the true hallmark of neuroinflammation. There are other more subtle ones that we can see earlier and we can see in the blood that I'll mention at some point in the talk. And then the next one, I'm going to do this, Amina, so I don't have to. So if we don't treat these patients, we know that when that inflammation occurs, there is a rapid progression of those lesions. And we know that there is a window where we can catch them, and a lot of you have heard the LES score, or LOES score, which has to be a certain number, and we say less than 10, to have really the capacity to halt the disease. And I don't know if you noticed that that red bar didn't go back to 0. That means that we treat here, and usually this is what we call rescue treatment, and those is hematopoietic stem cell transplantation, either by a donor or currently now approved by the FDA, by your own bone marrow, taken out, and with gene therapy, put back into yourself with the ABCD1 gene. What did we change? Primarily inflammatory cells that we call leukocytes, the ones that circulate, that live in your bone marrow and circulate in your body. They are not supposed to be going into the brain. And by doing that, we are able to restore this barrier and we are able to stop the lesions. But there is a lag between when you get transplanted and you get your new cells and when the lesions stop. And that lag is anywhere between 6 to 12 months, that the lesions continue to progress at a different rate. And I think this rate thing, how fast the lesion is moving, is where we are going to detect most of the data in this interim analysis. We don't have the outcome at 2 years yet, so I cannot tell you how they're going to do. But that's the parameter that we're going to be talking about. How fast are these lesions growing? And do they have this hallmark of dysfunction of that blood-brain barrier? And this is the schematic of your vessel and the cells coming into the space around the vessels first and then going and attacking the myelin. That's a nerve cell, and that's your oligodendrocytes that are kind of ensheath the axons that make the insulation to the wires. And if you don't have the myelin, and that's why these boys don't have a lot of symptoms, they are pretty asymptomatic and normal until the nerve cell starts to suffer. So you can do a lot with wires that are without insulation, but once the wires start getting really damaged, you're going to lose them too. And that's the rapid decline that we see when the lesions have gone that big. So we treat very late, at least from the bone marrow transplant experience, we know that we are not able to halt that disease effectively, like soon enough. Elisa referred to her son about this. Like, it was eligible, he was late, they gave it a shot, and this is what we see very commonly, that we are not able to halt the neurological progression. So the next one, please. And this is what we have as a new conundrum, thanks to newborn screening and thanks to the awareness that is increasing in the whole ALD community, because we have a lot of families that are now getting access to getting very long chain fatty acids and genetic diagnosis, not only in men, but also in women. And that kind of starts making more people being able to be scanned every 6 months. And I'm showing here what a classic very, very early lesion, and I zoom into the brain in that part that connects the two hemispheres that is called the corpus callosum, is this thing here.
okay? And if you can see, more than 80% of the boys are going to have a lesion in the back of the brain, which is this corpus callosum, called the splenium, and very small percentage will have a lesion in the anterior part of the corpus callosum, and that's going to be this kind of lesions. But the classic dot that you see between the top row here in the middle and how it grows and over what amount of time is something that we still don't have a good understanding. And the same way that we were talking about what we don't know about AMN and the progression in adults, I think we need to be humble that this is still a field of discovery because we now have boys that are getting scanned every 6 months. And these ones, the anterior ones, have very different symptoms because they affect the frontal lobe and not so much the visual pathways and the kind of things that we're more accustomed to see as early symptoms in cerebral ALD. So, and the next one. So for the inclusion criteria, these patients for participating in the Nexus trial need to have 1 dot, at least, of white. We try to make sure that we have at least 2 time points where we see that that dot is moving because some patients can sit on that for a long time, and we wanted to make sure that we are capturing patients that were active. And have a diagnosis of ALD, and then the next one. And the next, I don't know what's going on. And this is the second part of the lesion hallmark, which is, I told you the white patch, that we call it a flare sequence. When you give the gadolinium, this is no leakage. This is very early leakage in a small lesion. And this is also very poorly understood. Does it come all together? Is it in the center? Is it around? Is it a lot? Is it a little? It goes up, goes down. How intense it is? It's all a field of investigation. So the next one, and you know what? I can do it because of that way I don't, no worries. So this is another part that we are trying to understand. And Dr. Malak and Dr. Eichler have been working together for quite some time in trying to really start understanding what's the impact of even just having ALD at 5, at 6, at 7. Is it the same if I have it if I am cerebral ALD and I'm a teenager? And we do know that the age has an effect on that rate of progression. That's the velocity of these lesions moving. So the trial was also developed to capture primarily these kids that are in the most active, most rapidly progressive disease, which is 2 to 12 years of age. We basically try to leave people out of the puberty side. And whether you have contrast enhancement, which was the leakage that I was showing, yes or no, so positive or negative, GD, gadolinium, that we know for a long time that it changes the speed of progression of those lesions. This is the low score, less score, on patients with and without contrast that were studied at that time. So we know if you have that hallmark of inflammation, you're going to go faster. And that was very old data and collected with a lot of limitations. This was the best data we have today, and that's the paper that Dr. Raymond published a few years ago, where you can see, again, the story kind of repeats. The blue guys are the boys that have no contrast enhancing lesions, and the majority of them are very stable, versus the red ones that presented with the contrast and then start growing their lesions. The graph is kind of split it the other way. So it's going down instead of up when you have a bigger lesion. So we do know that to get that inflammatory cell into the brain, there is a process. So people that have ABCD1 in all the cells in the body are kind of in the normal permeability of that blood-brain barrier. And the barrier here is this lower part, which is the endothelium, the pericytes, and the astrocytes. And these three guys together, we call it the barrier. But as I always say, the endothelium is the customs guys. If the inflammatory cell, the RAN one, the leukocyte, wants to come in, has to interact with that endothelial cell. And it is the endothelial cell that at the end of the day will open the gate and let the leukocyte come into the brain, which is not supposed to be doing. We do know that ABCD1 deficiency, so having ALD diagnosis, will change the way that our immune cells behave and change the way that your barrier behaves. And we also know that not every boy gets cerebral ALD between 4 and 9 years of age. And we do know they can get it later in life, and we don't know how much is that risk. But around 40% will develop the disease in this time period. So there's something else, and that's that little like arrow coming, which is the second event. Something changes the threshold. And while you still have the long virulent chain fatty acids in the middle, something else has to happen for these cells to really cross the blood-brain barrier and get into the brain. When you look at this in MRI, we have techniques called perfusion imaging. So the top one is the classic, and I really zoom in again in the splenium of the corpus callosum, which is that black little square at the top. I think that's my mouse shows? No. Okay, that's not helpful. So the bottom, CTH and KAP, those are more sophisticated sequences that we acquire in some centers routinely. And that can tell you if you have a much more subtle change than the one with the white patch. So 13 months, and I just skip a couple of MRIs. This patient was getting MRIs every 6 months. 13 months later, we see a teeny, teeny, tiny dot. But when you look at the perfusion, which means the function of these little vessels in the brain, is not so subtle. You see a red dot. And that's what we started to see. And then the dot, which was teeny, teeny, beeny, now is a little bit bigger. I'm talking about millimeters, okay? And we see that the lesion is coming. And this is where I think it takes even 12 months from that red dot to see the contrast enhancement, the gadolinium positive. And this is what we are trying to really get more data, because I truly believe there's a window for treatment here. We should be able to kind of hold the horse until we get a new gene into the patient and supplement the therapy. So this is kind of in a little video, and you can see in white, the white patch, the T2 lesion, and in red, the perfusion of the microvascular dysfunction, that blood-brain barrier change. And you can see it again, and we'll loop again. This is without treatment, and you can see the lesion grows, but you can see how much bigger the problem with the microvasculature is. And then after treatment, bone marrow transplant in this case, you can see how the lesions shrink in the microvascular. Unfortunately, what we lose on our myelin is we don't have regeneration therapies, so it's lost and we don't see changes in the MRI. So this was the unmet need. We do have patients that have cerebral ALD, and the standard of care treatments, transplant, gene therapy, require an exposure to chemotherapy, require several months until the patients are ready to do the transplant, and this depends on where you live. I'm talking about disparities by zip code. This is a real one. And I would say more than zip code, country, okay? Depending on where you are, the lag to a bone marrow transplant, where I come from, Argentina, that's around 8-month average. If you are in Boston seeing Dr. Eichler, it's 5 weeks, okay? So it is really different, and that's why we keep pushing for treatments that are accessible and a little bit easier to handle for the rest of the world too. So continue growth post-treatment, as I told you, it's not that we arrest right away, it's that we do have a lag. Sorry. And we were trying to just go after that unmet need. And we do know that glitazone has effects on the blood-brain barrier. And Wolfgang showed you effects on different models and what it does for the kind of myelin. And it also kind of improves the function of that barrier and makes it tighter and less permeable to inflammatory cells. So this study, it was very similar to the study for gene therapy in the sense that they present with a lesion. The difference here, and I put it there, is gene therapy only included the population number 1. You had to have contrast enhancement to get treated. And that had to do with the fact that we also thought the cells need to get in, and if you have the blood-brain barrier open, it's better. And population number 2 is one that was also not so available, which is those patients with the early lesions before they get the gadolinium contrast enhancement. And that's why I spend time on the sequence of the lesion. We first get the T2 hyperintensity, the flare-positive lesion, and then get the contrast enhancing. This study is the first study to include patients without contrast. And these are now the results, and I'm going to start with safety first. There have been no withdrawals due to adverse events. The kids are tolerating the glitazone better than the adults. They have less edema. They don't have so much weight gain. And I put a comment, they have not had changes in their adrenal insufficiency medications. So, and that was something that we didn't know, and now we start getting data, real data from patients that it tells us that this is not an interaction. There have been no cardiovascular or hepatic events, and he's generally well tolerated, and the benefit profile, risk-benefit is kind of favorable to continue. And these are the main data. This slide captures what we are seeing and what we see up to now. Again, this is an interim analysis at 6 months. The trial will end at 24, okay? And you can see how many patients we have that had hit the mark. It's just too soon to say anything in concrete for what the effect fully in the clinical presentation is, but all the patients remain clinically stable. All of the patients show lesion deceleration. Remember that I told you we know a rate, and that rate is better understood with contrast, less understood without contrast. So population 1, we have a really nice comparison arm. For population number 2, not so. But still, all of them show lower than what we have up to date as natural history without treatment. And 5 of the 11 patients that were evaluated have met what is called the clinical radiological criteria of arrest, meaning the lesions don't progress over the course of 6 months. And these are that rate of progression. So if we look, what I was showing you before is the Lowe's score, and it was very flat. And you can see here what does the lesion volume looks like. So we draw each lesion and we calculated the volume, and we are tracking that every time the kid gets an MRI every 3 months. And then this is what it looks like. And that's the velocity. You can see the velocity of those lesions kind of decelerating. I want to point out that this patient here was doing okay, and then escape the treatment, we say. Like, we didn't see any more effect, and this patient continued to progress. And that is very unlike the natural history. That's what lesions usually show. And just to make the comparisons a little bit more simple here, and all the dots on the data in the screen, every patient, the intervals are below in month 0 to 12, 12 to 24. In red, you have the patients from the natural history, and this is patients from primarily the MGH cohort in Boston. And then you have the litiglitazone patients up to the time that we cut the data for this analysis in April. And you can see that the rate of progression, that velocity of progression, is changing with the drug, with the medication, favorably. And again, because I know the audience and I wanted to see all this data, I just put it for maybe the scientists and the doctors in the room, but I wanted to show you what the two populations look like, because I can still not believe that we can alter the contrast-enhancing population versus the contrast non-enhancing population, which we have more patients than in the contrast-enhancing. So in red are the ones gadolinium positive, in green, the gadolinium positive, in orange, the ones that are negative. And you can see that the velocities also are affected in both. So this drug seems to be having an effect on both lesion size progression. And I'll tell you a little bit about the blood-brain barrier part, which is not so easy to conclude. And this is a comparison now of those rates of lesion growth between untreated, red, litiglitazone, green, and what you see in blue, which is a small number of patients, is bone marrow transplantation, conventional bone marrow transplant. And this is after we were able to publish what the gene therapy is looking. And I just took only 3 to 6 months because we don't have data, too much data. It's 3 patients we have like kind of on the longer term. I took the early data and I didn't do 0 to 6 because litiglitazone doesn't have any delays between the MRI and when the treatment starts. We basically do the MRI and start the pill. While transplant and gene therapy, the MRI happens, there are several weeks, up to 6 weeks before the treatment starts. So it was very difficult to standardize those measures, and we just took one that all of them have the same: gene therapy, bone marrow transplant, litiglitazone, and the untreated cohort in red. And I put a couple of representative cases, but just this is what was published before with gene therapy, and just to kind of what the white patch should look like when you get effect of a treatment. And that's what the natural history does. If you let it be this 2-year interval here, 1 year, 2 years. And this is the contrast enhancement that we were talking about. And the gene therapy showed that it can resolve that contrast enhancement, make the blood-brain barrier better significantly. And this is a patient with leriglitazone, and I put the lowest scores and the contrast enhancement score. The HIS was 1 to 3. 3 is the highest and the worst blood-brain barrier permeability. 1 is still enhancing, but not as bad. And you can see this lesion is in volume, staying the same, and the contrast enhancement is improving. Because this patient still have a lesion and contrast enhancement, and the lowest score scores the internal capsule, this patient goes to transplant at 12 weeks was the indication. And this patient is from Latin America, and he couldn't get to transplant until much later, and the family asked if they could stay in drug. And that's what we've been doing it all along. If the patients get their that match donor assessment before they get into the trial, they move from where they live, and they get the treatment, and then if the lesions are not arresting, they have to go back and do the transplant where they are from, which is in preparation, and some of them, the preparation is not ready. It was that lag that I was talking about of several months. And this is what happened to the patient. If you guys are asking, this is how he entered the transplant. This is the last MRI right before the transplant started. And this is the MRI 9 months after, and it's still the MRI to this day. So the lesion fully arrested. But as you can see, there was significant growth there. That is also what we know takes, not atypical for bone marrow transplantation to see lesions that are progressing until they fully arrest. Here's another patient, and I put the subject numbers up there, and the lesions in the white patch, and you can see it in the different month. This is a zoom in into that patient. This patient is a 5-year-old, and he has that lesion in the back, and we're very concerned about this patient because younger patients tend to progress and progress faster. The lesion is showing that it's decreasing in size, and the contrast is, as you see it in the previous slide, is not very conclusive, but it's still there. So this is the conundrum of what do we do? Do we transplant this kid? Do we send him to gene therapy? Or do we keep it in the study with leriglitazone? We don't have enough data to make those decisions fully informed. And this is another patient, and here the patient he doesn't have contrast almost at presentation, and you can see over the course of 48 weeks what the lesion looks like, and the things plotted. I'm gonna speed up here. This is the microvascular function that I was talking about. You started seeing the normal, and as if you are an ALD and have these inflammatory cells that are interacting too much with your endothelium, you slow down the flow, and at some point that breaks the barrier, the cells start coming out of the barrier. The point here is that blood flow, we can see in MRI. So that's why we use the perfusion analysis, which is the way that the brain usually works all the time to adjust the blood flow. And these fancy formulas will give us something called capillary heterogeneity. So if you are working with maximum function, that is usually a low number, and if you're having troubles, it's a higher number. And we call it CTH for one of the variables and K up for the other. We know ABCD1 changes these parameters before you get cerebral disease. And this is just to put what these parameters look like, and by population. Population number 1, gadolinium positive, and 2, without contrast. And the comparison between the two populations is negative. There is no differences, but we do see an effect of improved microvascular function in patients with comparison to the natural history that is untreated in red. And when you go to other biomarkers that we understand are representative of neurodegeneration, but you take them from the plasma, that's called neurofilament light chain. We see also a trend towards the same findings that Dr. Troitland and Johannesburg published previously, which is that after treatment, over a course of time, this neurofilament light chain that is elevated on the kids with cerebral ALD and the adults too, starts normalizing. And you can see again in black the patient that unfortunately did not respond to the treatment, that the neurofilament light chain is also reading that lack of response. It's just telling us how the lesion is also progressing. So we see some signal here, and these are the conclusions in summary. All the patients met, well, the study itself met continuation criteria, which was what I described at the beginning. So they all can continue, the ones that are in the study. Is safe, is well tolerated, and we have early evidence that the disease is stabilizing. by radiological, okay? All of the kids have the exact same NFS, so the neurological function score, that they have when they enter the trial. So none of them have gained or suffered neurological dysfunction or deficits at the moment. And we see this marker that is a little bit more sensitive than just the white patch, which is the microvascular function and the perfusion and the blood-brain barrier going in the right direction. The truth is, we gotta wait until year 2 to get the full assessment of how these kids are doing to draw any conclusions. But this data that I'm showing you also went in to, at the request of the regulatory agencies, to support the data that Wolfgang was presenting for ADVANCE and the data that was seen in cerebral ALD in the adult side. And as I was saying, this enrollment closed in May, which saddens me a lot because a lot of the patients that couldn't access bone marrow transplant or they're in waiting mode are not going to be able to get treated in excellent centers like the ones that are enrolling for Nexus. And this wouldn't be possible without amazing mentors sitting in the room, including Dr. Eichler and others, and a community of incredible collaboration, which is a privilege to have. Doesn't exist in every disease, guys. What you have created in ALD, keep it, and keep it like that, and keep it growing. It's not easy, and not every disease community that has a rare disease has everybody in the room. Like the patients to start, the scientists, the advocates, whomever is gonna do the drugs, and the clinicians caring for the patients. So a privilege to have. I started in ULF 2008 was my first meeting. Dr. Eichler said, go present the perfusion thing. And I met Elisa, among others, and I just couldn't stop working on ALD since then. So don't underestimate the impact that you guys have sharing your story with the scientists and the clinicians, and as young as you see them, it might be the change in their career for the rest of their life. So with that, I'll stop and I could take the questions.
So I'm a sub-PI for the site for the CALIX study at Kennedy Krieger Institute. So just happy to introduce this to you on behalf of Minarex. Okay, can you advance please, Patty? All righty. So again, this is a new study, and so the population that we're looking for are adult adrenal leukodystrophy patients with progressive cerebral adrenal leukodystrophy that are not recommended for hematopoietic stem cell transplantation. So the idea is if that you're a good candidate or sort of in serious talks to undergo HSCT, you're not a candidate for this study. So this is placebo-controlled, is randomized with 1-to-1 with open label extension, and I'll go through the timeline, talk more about those details in a moment, targeting a sample size of 40. And there are a number of sites in the US, which I'll review at the end, as well as a couple sites in South America. So there is a 36 months total duration, and the primary endpoint, essentially survival, so time to death, or bedridden with permanent ventilatory support. The secondary endpoints, there are many. Radiologic, and I know several people during this session have talked about the LESS score, and also there's going to be some clinical, so the functional disability scale, activities of daily living scales, time to major neurocognitive impairment, neurologic function, simple digit modality test. There are a couple of global impression scales from the clinical perspective, and then the Euro quality of life. So really gathering a lot of information, and of course, as always, will be safety and pharmacokinetic measurements. So inclusion criteria are males with X-linked adrenal leukodystrophy older than 18, progressive cerebral adrenal leukodystrophy, HSCT not recommended by the investigator or the patient unwilling to do that. And there need to be gadolinium positive brain lesions. Exclusion would be a LESS score of greater than 12, or a history of previous stem cell transplantation or gene therapy. Okay. So again, just to give you a little bit of information on the timeline for this multi-center randomized placebo-controlled trial. So there's the screening in the beginning, that's a couple of weeks. So I don't forget, this is an important point. So of course, for inclusion and exclusion criteria, we need those MRIs up front. and noting the LES score, looking for the GAD positive lesions. And so it's a lot in terms of time and expense, we know, for patients to come to these centers, even though there are a number of them across the US. So Minarex is actually going to be funding patients to be able to travel and have those MRIs done for free. And there'll be sort of a link to find out more about that at the end. So once the screening takes place, if you're eligible, you'll be in the placebo or the liraglutide arm of this study. And importantly, there's 2 interim analyses. The first is at 18 months. And so there'll be assessment of the primary endpoint. And at that point, if it looks like there's efficacy of the drug, everyone who received placebo will actually go into that open label extension and be treated. The patient and the study staff will still be blinded the whole time, but again, if it's efficacious, you'll be treated. And so then otherwise, if not efficacious, continuing with the placebo and liraglutide arms until 27 months. For the second interim analysis, same thing. If there's efficacy, there's an opportunity to then basically reassign over to the open label extension with the drug. And the final analysis would be at 36 months. Okay, we can continue. So again, I talked about the primary endpoint, so overall survival being the main thing, and this would be death or the subject being bedridden, requiring permanent ventilatory support. I talked about the endpoints, so keys again are LES score, time to increase of at least 1 major functional disability scale score, the ADLs, and time to major neurocognitive impairment. And then a number of other secondary endpoints as well. I think maybe of those I didn't mention previously would be biomarkers in the CSF, or sorry, in the plasma, neurofilament light chain. Okay, so then the study sites, we're getting started. So we had our site visit and are getting set up in Baltimore. We should be ready to go in just a couple of weeks. Ali Fatimi is the principal investigator. I'm the sub-PI there, but we also have sites, Minarex has sites in Boston, Stanford, Minnesota, Florida, Utah, and then 2 sites in Brazil and Argentina. And I'm sure a lot of the names of the investigators are familiar there. And so kind of here we are at the end of June is when we anticipate that the Kennedy Krieger site will be fully activated and ready to go. And this is sort of the rest of the timeline for the interval analyses. Okay, so so we are standing by, ready to enroll patients. The remaining U.S. sites will also be starting up very soon, July through September, for enrollment. And of course, if you're interested in joining, interested people can contact the centers directly if you're already seen as a patient there, or you can access the recruitment website. So that's www.cald-study.com. Don't go to it yet, though. I've been told it's not quite ready. You have to wait until Monday the 26th. So this is all kind of really, really new and exciting. All right. Thanks for your attention. And I'm happy to take any questions. I also have a mystery from Minarex who could help as well. Yes, ma'am. Actually, I don't quite remember the university. It's, if we can go back to that slide. Oh, it's okay. Just two slides back. Maybe if I can even see the investigator, I'll. Yeah. So it's Hans Schuiber is the investigator. I'll find out. I just don't remember off the top of my head. Yeah. Okay. Great. Any other questions? All right. Thanks. And just, again, if you're, I know a lot of people in this room might not be eligible, but really any males with AMN, it's at least an opportunity, especially if there's not been an MRI recently, to get funded to go down to a center and have a screen done, because that needs to be done annually anyway. And we know we're probably going to have to screen a lot of people with AMN before we get to that target of 40. All right. Thank you. Mm-hmm.
Our son has been seen at Kennedy Krieger numerous
Okay. Mm-hmm. That's a really good question. And so that was actually at our site visit at Kennedy, we asked the same thing, if that would be possible. I don't know if you have an update, Aaron, about the ability to use as that initial screening MRI a local image. Yeah.
Thank you. So it's a very good question. If there's any findings on that MRI, it's likely that we will need to repeat it because we need to use the same machine for all of the visits within the study. But it doesn't matter that it's done first locally. If it's identified that there's lesions or anything else, then yeah. So absolutely, it opens the door to the study.
Travel to Baltimore.
We will support all travel as needed.
It's yeah, good question. It's men. It's at least 18 years of age. Men at least 18. Yep. Any other questions? Okay, thank you.
I'm sorry not to be with you in the room. It would be more easier. Sorry again. And let me start. And I would like first to thank the ULF to give me the opportunity to give me this presentation. This is my disclaimer. Okay. So just some words on a Poxel company, which mission is to discover, develop, and commercialize innovative therapies for patients suffering from serious chronic disease, such as type 2 diabetes and non-alcoholic steatohepatitis or NASH, and is, of course, focusing also on rare disease with underlying metabolic pathophysiology, including X-linked adrenoleukodystrophy or ALD. So at Poxel, we have two proprietary programs with two drugs, named the PXL770 and the PXL065, with two different mechanisms of action, identified for their strong potential to be developed for the treatment of ALD. And I will come back in the coming slide on the preclinical package we have today on these two compounds. Importantly, orphan designation was granted for the two compounds in US and Europe for ALD, and fast track designation has also been granted for the two compounds, which may help expediting their development. These two compounds are, I would say, major compounds in their development program and ready for phase 2 in ALD. Indeed, these two compounds have already demonstrated their efficacy in phase 2 trials in patients with NASH, and importantly have shown a good safety profile. These results of these two phase 2 clinical trials have been published in two peer-reviewed journals. First, the PXL770, it is a direct AMPK activator, which is a master cellular energy sensor. Activation of AMPK modulates several metabolic pathways and has other key effects to attenuate inflammation and support cellular functions, which are part of ALD pathophysiology. Several lines of evidences support the potential to target AMPK for the treatment of ALD. Indeed, AMPK activity is reportedly suppressed in cells and brain tissue obtained from ALD patients. also deletion of AMPK in cells from classical mice model of ALD, which is the ABCD1 null mice, lead to a more severe phenotype. In addition, metformin, a weak and indirect AMPK activator, was shown to induce the expression of a compensated ABCD2 transporter in ALD model systems. As I mentioned previously, the PXL 770 was already tested in human in patients with NASH, and it was the first opportunity to see that the clinical results observed during these phase 2 trials did confirm the preclinical findings reported in NASH models, which means that we could also expect to see a good translation of preclinical data in ALD into clinics. Of course, we have now to run the clinic to confirm. Here it is the PXL, the second compound, the PXL 065, which is a new chemical entity derived from pioglitazone, or PIO. PIO is a commercialized anti-diabetic drug. It is also a one-to-one mixture of two compounds, two enantiomers called R and S, which exhibits two major mechanisms. One through a genomic pathway via PPAR gamma agonism driven by the S enantiomer, and the non-genomic pathway driven by the R enantiomer, involving the inhibition of the mitochondrial pyruvate carrier, NPC, and the acyl-CoA synthetase 4, SCL4. PXL 065 is a clinical stage deuterium stabilized R enantiomer of pioglitazone, lacking PPAR gamma agonism, but retaining non-genomic activity, which includes, as for PIO, two targets, the inhibition of the MPC and the inhibition of the SCL4. Both of these targets affect lipid metabolism. MPC inhibition results in greater fatty acid utilization, and secondary effects to reduce inflammation. MPC is also implicated as a target for neurodegeneration. SCL4 is a key enzyme that is involved in lipid peroxidation, leading to ferroptosis, which is a form of a cell death. So the objective of this new derivative zone is therefore to maintain PIO efficacy, but limiting its side effects, such as weight gain and edema. The scientific rationale for the PXL 065 is based on published data of pioglitazone, showing its potential to attenuate neuroinflammation and confers neuroprotection. PIO efficacy has also been published in ALD mice, the ABCD1 null mice model. And the last but not least is relative, as mentioned in the previous presentation, to leriglitazone, which is a metabolite of PIO and is also active in ALD models and has shown evidences of efficacy in patients with AMN. Aligned with the limited PPAR gamma effect measured with the PXL 065, it has been confirmed in the phase 2 clinical trial in NASH patients, a good safety of 065, which is, with no dose-dependent effect on body weight and no peripheral edema, which are two well-known PPAR gamma side effects. In this study, the efficacy of the PXL 065 has also been proven and the exposure of the R enantiomer was dose proportional. Based on these rationales, we developed preclinical data for both compounds, which demonstrate substantial efficacy both in AMN and CALD patient-derived cells. So let's turn now with this data. We have generated in collaboration with academic partners, especially the team of Jasprit Singh, based in Detroit. So here are some examples of this data. In vitro, in a fibroblast for AMN patients, the two compounds strongly decrease elevated C26 VLCFA, as you can observe in the two graphs on the top. In parallel, an increase in the compensatory transporter, the ABCD2, has been measured and maybe involve and contribute to this decrease in VLCFA levels. This result has also been replicated in CALD patient cells and also in glial cells coming from the ALD mice model. So we have, in addition to this in vitro panel of preclinical data, we have developed preclinical data which demonstrate substantial efficacy in the classical ALD animal model, the ABCD1 mice. Both compounds induce substantial reductions in elevated VLCFA in plasma and in the spinal cord, as you can see here on the top graphs. And this has been also observed in the brain. The effect of the PXL065 and the PXL770 on behavioral and locomotor phenotypes were evaluated in this model after 12 weeks treatment by oral gavage. In these animals, neurological improvement was seen by an improvement of the mice behavior monitored during the open field test for the 065 and the balanced beam test for the PXL770. Axonal morphology based on electron microscopy of the sciatic nerve is also improved, as shown by a reduction in the stellate-shaped cells proportion. So from these preclinical data, we have seen that both PXL065 and PXL770 acting on different pathways are able to decrease the accumulation of VLCFA, which is the primary driver of the disease. It is also described the benefit of this pathway acting on the mitochondria, which is involved in the decrease in VLCFA accumulation. Interestingly, both compounds are also able to reduce inflammation and reduce axonal cell death. So I haven't shown you all data, but all the full package of this preclinical data for the two compounds were published last year, and you will be able to find more data, including the benefit on inflammation in ALD models. So based on this preclinical package and the knowledge we have with this compound in clinic, of course not in ALD, but in NASH, we are planning to initiate two parallel and identical phase 2 biomarker-driven proof of concept studies in patients with AMN. So one with 065 and one with a 770. We have open US INDs for both molecules. The objective of these two lean short studies are to confirm the effect of two compounds on, particularly on VLCFA, before moving into a long pivotal trial. The team is now fully prepared to initiate both trials, which will enroll adult male patients with AMN. Each trial which enroll up to 12 to 24 adult male patients. And following a screening period, patients will be treated for 12 weeks with one or two oral daily doses of either molecules. Readouts will be pharmacokinetic, safety, and the measurement at several time points, the VLCFAs. Neurofilament light chain will be also assessed, as well as additional exploratory biomarkers. So to conclude, we have seen that today we have completed a very encouraging comprehensive preclinical package for these two compounds. We have initiated the preparation for the two clinical studies in AMN, waiting for additional funding to launch these two studies. But this remains a key priority for the company, and to run these studies and to continue to work in ALD. So So as I mentioned, we very importantly we get a regulatory designation for the two compounds in US and Europe, particularly for orphan designation. So we, as a company, we remain very excited to pursue treatment for ALD. As we all know, it represents an area with a very high unmet medical need. So thank you for your attention.
Do we have any questions in the room here? Please introduce yourself.
Hi, Elise Vivar from the European Leukodystrophy Association. Just a short question, it's early, but what do you expect clinical outcome for your trial?
Sorry, you ask
what
our
do you
expectation.
Yeah, what are the clinical outcomes?
For these two clinical studies,
Yes.
correct? Okay. Okay. As I mentioned, it is a lean, short study. Our expectation is to confirm the main profile we achieve in the preclinical package with this strong decrease in VLCFA. Of course, we will take the opportunity to look at additional biomarker, and in parallel to prepare the pivotal study and to get and to consider this result to design this pivotal study.
And just to go a little further down the line, I know it's very early, but what would be the long term, if you do the clinical trial phase 2, the long one that will, what would be your clinical endpoint, your preferred clinical endpoint?
For the pivotal study, you mean?
Yeah.
For the next study?
Yeah.
Yeah, we are working now of this design. Of course, we have in mind two key endpoints. we think we have to follow is to use the 6 minutes wall test, but also the body sweat test. We are thinking that it is a very important marker to follow to assess the efficacy in patients.
Thank you so much.
So yeah, I am Lisbeth. I am a clinical research coordinator working with Dr. Florian Eichler. One of my main studies is ALD women. And today I just want to kind of run you through the different studies that we have at our site and answer any questions that may arise. Next. So here, first I just want to give you an overview, a timeline of the last 40 years, different studies or the larger studies that have been done in females with adrenoleukodystrophy. At this point, we know that females are not just merely carriers, but they experience symptoms, and in the last 10 years or so, we've been able to learn more about the prevalence of these symptoms and how they become more prominent as women age. So what do we have, what studies we have currently going on at our site? So we have this umbrella term of ALD women studies, but under that we have different things going on. So we focus on movement disorders, collecting data retrospectively through medical records and chart reviews and literature review. We also have perspective data that we collect from females that come to our clinic, and natural history, just learning more about the prevalence of symptoms and symptoms progression in the population. Sounds good? Okay. And I also wanted to talk about our leg discomfort study that I will cover at the end. So first, with the movement disorders, we've been in collaboration with movement disorders experts at MGH, and we have collected data through medical records and literature review, as I mentioned, also prospectively, just seeing patients in clinic and doing some assessments. And from the data, we've been able to see that one of the most common symptoms experienced has been ataxia or poor coordination. Also, we've been seeing tremors that can be seen in the hands, also in the head or neck as what we call head titubation. We've also seen dystonia, which is this head or neck tilt you can see in the picture over there, and also speech abnormalities that can be seen through voice tremors. But the main takeaway is that we're seeing these movement disorder symptoms independently from brain involvement. That's different compared to what we see in male. Another project that I've had the opportunity to work on is with our neuroradiologist, Otto Rappolino. And we reviewed MRIs from females with adrenoleukodystrophy. We had a cohort of 17 that we were able to obtain MRIs. And so we collected data on age, gender, also on different MRI features, and we also had a control population of other 17 that were matched based on age and gender. And from this is all preliminary data. We still don't know exactly what's going on, but we were able to observe that there was a correlation, or we were able to observe a statistically significant more white matter abnormalities in females compared to the control population. Additionally, as I mentioned, we've been collecting data retrospectively through a chart review. I was able to work with Dr. Yerali and also one of our coordinators, Natalie Grant. We were able to identify 79 patients from our cohort, patients that we see in clinic, and from dates from 2007 to 2022, and we found that almost 90% of all the patients of this cohort experience at least one symptom, with the most common being impaired sensation in the lower extremities, also pain, discomfort, bladder dysfunction, and gait or walking difficulties. So at this point, I've shown you data that we've been able to collect retrospectively through medical records, as I said, or chart reviews, but there's a couple of questions that we just can't answer by just looking at, what we have in front of us. Some questions require a little bit more digging, so asking you, going out there and seeing what factors are impacting you in your care, or how quality of life is affected in females with adrenoleukodystrophy. Also, what barriers to receiving the care that you need, and what interventions or strategies you use that you find effective in you that we can go out there and share with others. So for this, we come up with what we call the interview. It takes about 30 to 60 minutes to complete, and it's just a series of questions going over like symptoms and onset of symptoms, so when you started feeling pain in your legs and things like that, and also covering questions on quality of life, mental health, and what are those biggest contributing factors that are impacting your quality of life. So we currently have conducted 31 interviews so far. I don't have all the data here, but I just want to give you a quick glimpse of what we've collected so far. So we've been able to learn that from those 31 patients, 84 has reported that they have been facing barriers to getting the care that they need, with the most common being facing that lack of knowledge among providers, local providers. So they go to their doctors, and their doctors just really don't know about ALD, and some of them feel like they know more than their local doctors. Others, barriers have been facing doctors that they just don't believe that they have ALD, and among others. Also, we covered, we asked questions about quality of life, and 84% of the population of the patients mentioned that they have, ALD has an overall impact in the quality of life, with 1/3 of them saying that this impact has been severe. And one of the, sorry, go back quickly. And one of the most commonly reported contributing factor has been how other family members have been diagnosed with ALD as well, like children, and just like that guilt that comes with passing on the disease to their children. Other factors has been physical symptoms or management of care, and also how the diagnosis has impacted other family members, like their spouses or husbands and all that. And lastly, I wanted to talk about the current trial that we have for females with adrenoleukodystrophy. This is funded by the European Leukodystrophy Association, and it's in collaboration with our team in Amsterdam, Dr. Mark Englund. So this study will be covering leg discomfort, but leg discomfort can be due to different factors, such as neuropathy or peripheral nerve damage. It could also be due to spasticity, vascular insufficiency, as well as restless leg syndrome. So we will be focusing on the latter. So restless legs is characterized by this uncontrollable urge to move the legs. And one diagnostic tool that has been very helpful has been the URGE acronym. So URGE, U stands for that urge to move the legs that is usually accompanied by unpleasant sensation that tends to get worse when patients are laying down or are not moving much, but tends to get better as they stand up and move around the house. And E stands for the evening, meaning that it tends to get worse in the evening or night. We can go back quickly. So just to give you a little bit more background on RLS, we conducted a pilot study. We conducted a pilot study with on both females with ALD, also with males, and we found that 40% of this whole cohort experienced RLS symptoms, females being more commonly affected by RLS than male. And also from our chart review that we conducted on just females, we found that 35% of our cohort experienced symptoms, with 2/3 of them using medications for management. So the trial will be broken down in 2 different phases. So phase 1, will happen very quickly. It's just 3 remote visits, and any females with adrenal leukodystrophy can be part of it. So you could be asymptomatic or symptomatic. Just 18 years and older will be the only criteria there. So the goal of this part of the study is to learn more about like discomfort in women and the prevalence. We'll be conducting questionnaires and phone calls asking about spasticity, neuropathy, other symptoms, and also mental health. And we will start enrolling in July. That's the other thing. And phase 2 of the study, this is going to be more interventional. So only those that are eligible will be part of the study. The goal of it was going to, to determine if pramipexole, an FDA-approved drug, will reduce significantly the RLS symptoms in the female ALD population. So the study will take place it takes about 4 months or so. So the first 8 weeks, patients will undergo treatment with pramipexole or placebo, the sugar pill, and we'll be assessing. They will come throughout the study 3 times in person, and we'll have sleep studies done. So they come, stay at our sleep lab overnight. They'll also see Dr. Florian Eichler for neurological examinations and other walking tests and other things like that. And after the first 8 weeks, patients will undergo a switch-over visit, and they will switch to either pramipexole or the placebo, depending on what they started with. Enrollment, we plan to start in October. And that's it. That's what I have. I just want to say thank you, and that's my wonderful team over there. And any questions? Yep.
Wait. If you have the ALD or just restless leg syndrome?
So for the first part of the study, we'll be collecting also genetic information or biochemical to see if you have very long-chain fatty acids and things like that to confirm that you have ALD. And then we also will be conducting one of our questionnaires will be on RLS to see if you have RLS or not. And we have an RLS expert that will be conducting those.
Where will this take place?
So the first where it will take place?
Can you repeat the question?
Yeah,
Sorry.
so where it will take place. So the first part of the study, it will all be remote. So essentially this will just be phone calls with you, and we'll go through the questionnaires then. And then if there's any information that you need to send us, like genetic tests and things like that, that can happen over email. Yeah.
Sure. I have most of those symptoms.
Yeah.
Now, will you have to go through your primary care doctor for this?
Not necessarily, unless we need some sort of, not really, no. If you have the genetic information or anything that we need from for eligibility for part 1, then no. But if we would need anything from your primary, we can also just request information directly. Yeah.
So my husband had the disease, and my daughter is a carrier. So she did have some mental issues, like with depression and anxiety, and she still has anxiety and stuff. So would she be like a good candidate for this study, or
Yeah.
Adonis?
Yep, the only, at least for part 1, the only eligibility that we have is that you have ALD and that you are 18 and older. So yes. I can also give you my contact information at the end, so you take it with you. Yeah. Any other questions? Oh.
I would like to mention that you may motivate the women and every woman to be part of the international questionnaire on quality of life, which is available on LuConnect from ELA. There are more than 200 women already from all over the world, and it's available in 5 languages.
Wow. Nice.
So it takes just maybe half an hour or an hour to fill in the questionnaire, so it's an international effort supported by ELA also. So I would like to motivate all women to
Sounds good, we can do that. Thank you.
It's the ELA website, ELA, this one.
The
Yeah,
European
and then
Leukodystrophy.
and then you will find it. Yeah. Leuconnect.
It's the European Leukodystrophy Association.
And I will put a pitch. Where is this one? Is that the website there? This one? No.
No.
It was in the slide just a moment ago. No, we don't have it. But I would recommend that people just go and connect with the ELA and the sites that she mentioned, and they can answer the questions and guide you. And also, if it's not this study, what studies are out there that women can participate? Very important that we have women participating in the research.
And feel free to, can you go back to the other one? Sorry. Not that. Yeah. Feel free to also have my email too for any questions.
Excellent. So, as customary, whenever I'm in the room, we are like half an hour late. It doesn't matter if I do it or not. It's just my influence is very strong. Thank you so much, all the speakers, all the attendees, all the families, and for being here and for making this a very successful session.